Oh yeah, now that is one way to introduce SkyTour LiveStream. Some cool bluesy music in the background. That's really nice. But I just want to welcome everybody. Hey, welcome to SkyTour Livestream for today, April 22nd, 2020. We're gonna look at the comet. We're also gonna keep our tabs on the planet Venus, which you can see on the screen. And we will be doing even more beyond that. We're going to check out a few other things. And, we're not just going to look at Comet. We're not just going to look at Venus. We're going to look at other things, as I said. So it'll be kind of cool to do that. And I will make sure that we look at as many things as we can while the night is good. And, in fact, in terms of the night being good, let's take a look at our sky cam here. Right? I know that looks like clouds, but it's not. Okay? It's not clouds. Actually, this right here is the planet Venus that you're seeing, that little dot up there. This is actually a very dark sky that's coming. Right? It's just not there yet. We're taking a time exposure with a very sensitive camera. Right? But not a cloud in the sky. That's what we want. Excellent. So, back here, this is Venus right now. We're going to take a quick shot of it and then zoom in to show you what we got. All right, so this is the planet. Let me just... What's that?
You can't fool me. I said, that's not Venus. You can't fool me. That's the moon.
Yeah, right. Actually, your mic just got really low all of a sudden.
Yeah.
Yeah, I don't know why.
I'm where I was.
That's very odd.
Anyway, hi everybody. Do I sound better now?
Yeah, a little louder, but you're not... maybe you're... Well, let people tell you how you sound. Right? You were fine until we actually started a stream. Then all of a sudden, it wasn't good anymore for some reason. But check it out, guys. This is Venus. This is... if you notice, it's actually less illuminated tonight than it has been on other nights. It was almost 50% illuminated, just under 50% when we saw it. And now it's even smaller, and it's going to end up being a very small crescent, but I say small crescent, be a thin sliver, but it's going to be bigger in the sky than this is right here. It's actually coming toward us right now in its orbit, and it's going to be closest to the Earth when it's largest in our sky. So that'd be pretty good. Hey, Farva, thank you. That's very kind. Farva just got a telescope today, guys. He actually he asked me about a telescope, what might be a good scope. I sent him to get a Mead, and it arrived today, and he's all excited, and I think he should be. It's going to be a very nice scope. And, of course, if you have any questions for me, Farva, later, when you start pulling it out, you can feel free to ask. But, being sort of a kind of a explorer at heart, I may point you in some directions before I actually give you any direct answers. But we'll see. Okay. My hand sanitizer took a dive. Okay. So yeah, there's Venus. Look at how beautiful it is. It's looking kind of yellowy, which is kind of nice. I set the exposure ahead of time just to let you know. I set the exposure ahead of time just so we can kind of see it like this, and maximize the colors that we might get to see. Pretty, isn't it? What do you think, Daryl?
Sure. And it's showing off that color of Venus's cloud tops too.
Yes, it is. Yes, it is. Indeed. So I just want to say hi to everybody.
Sulfuric acid looks like.
Oh yeah, yeah, not pleasant.
Folks, can you hear me? Okay.
I'll wait for them to respond.
Okay.
I'm hoping they can hear you okay.
You sound kind of loud to me.
I am?
Yeah.
Well, all right. Well, Eugene Schnitger is here. Hey there. I see a bunch of people here I should say hi to.
Hello, everybody.
Yeah, Daryl. Daryl is a regular on SkyTour Everything. He's a co-host on SkyTour Radio on KGRA Radio, Sunday nights from 8 to 10 p.m. Eastern Time. And you sound good according to Marianne Robb. So there we go.
Alrighty then. I'm going to try to bump it down a notch.
No, don't bump it down. If anything, it's going to
Well,
go up.
okay. I'll compromise there. Hopefully it's still good.
It sounds fine to me.
Alrighty.
Yeah. So what we're talking about here is, we're actually looking to get over to Comet Atlas again. I actually did a private night of observing the other night, and spent a lot of time catching a lot of imagery, and I actually sent Daryl in Skype some galaxies and stuff, and it looked really cool. They were really, really pretty. So I was really happy to see that. I was glad to see that it came out so well. All right.
Yeah, nice pictures they were too.
Yeah, we got the M81, the Messier 81 galaxy, and right next to it in the sky and in space is one called Messier 82, and we got that here, and we actually took about 20 of each and stacked them, and you could see tremendous stuff. Yes, Kathleen Solway Kessel, this is Venus indeed. We just took the picture moments ago in the sky. Actually, let me show you what it looks like in the sky. Okay, this is how big it is in the sky right there. Okay, now we can do a magnified view, and I use this just for focusing. All right, but this is a focusing view that I'll use, and I'll just move this over just so you can see where it goes. Okay, so this is not a very good view of it because I'm actually zooming it for purposes of focusing. All right. So, but then we take off the focus, and then we get out of the focus view. Now, if we take a photo, this photo here, for those joining us, this is the telescope control system here, along with the filter wheel. Right now, we're looking at visible light, the light you see with your eye. This is me. Hello. Okay, you can see me waving. Okay, and operations. This is, on the other side here, this is the dome cam, which is currently set to not be in infrared mode, and I'll change that here in just a second. Might as well just turn on the infrared now because it's looking like we're going to need it. There we go. Now you can see everything once the infrared camera's on. And this is the camera control system over here. You can see this here is the exposure setting. Right now we're doing a 1/800th of a second shot at 50 ISO. 50. The camera can go up to 409,000 ISO. That's the sensitivity rating. So it actually has quite a range. And hello, Amanda.
Hi. Sorry for the lateness.
That is okay. I sent her a message saying please join when she got in.
Hello, Amanda.
Hi, Daryl. How are you?
I'm okay. How are you?
All right.
Mark, you need 2 more pictures up on your screen, one of Amanda and one of yours truly. But then you wouldn't have any room left to show us astronomical delights.
Well, I actually used to do that. I had that on the left side, remember? We did those pictures on the left.
I think I
Did we do that here?
That was on a KJRA stream, wasn't it?
Oh,
That's what I thought. I thought Bill put them up on KGRA.
Oh, okay.
Shepherds.
All right.
That's okay, though.
Well, Dave, you're always telling me you don't want anyone to see your picture.
Well,
So
maybe.
I was
I
kind
think
of...
everyone's good without my picture. That's all right. Let's
No,
leave more room for...
Oh, nonsense. I can get rid of some. I can get rid of me. Who needs to see me? And we can put you there. We can put Daryl there. Actually, you know what I'd love? I'd love to see whoever's talking at the time show up there.
That'd be interesting.
Yeah. I mean, Skype does that now, actually.
yeah, Skype kind of automatically does that.
Yeah, so I'd like to know how we can do that and put that picture there to make that the active one. There's got to be a way to do that programmatically, guys. So this is Venus we talked about. I'm going to take a picture at, we're actually going to go a little bit longer exposure and just make it a little brighter. All right, at 50 ISO at 500th. This will be a very quick shot. Here it comes. Don't blink. All right. And then we just bring it in here and you can see there it is. Okay. I'm really, as Venus gets closer, all right, the colors seem to show up better in its atmosphere, and we're actually seeing this yellowish tint of the upper cloud deck on Venus because it's really kind of yellowish. It's wonderful to see it.
Is
And
that sulfuric acid?
yeah, it's H2SO4, 2 hydrogens, sulfur, and 4 oxygens. H2, diatomic hydrogen, sulfur, S, and O4, 4 oxygens. It's amazing how when you combine all these elements in the periodic table in certain ways, they make things that can be deadly to us. I'm really surprised that, as a kid, I was so surprised that things could be dangerous at all, because it just seemed like they're just chemicals. I couldn't figure out why they should be so dangerous. But you take a carbon atom and bond it to a nitrogen atom, and you have cyanogen, which is obviously, the derivative of cyanide. So we know that's dangerous. So it's like, wow. So, we are in a very tenuous position as humans. We breathe oxygen. We use oxygen to make energy for our body functions, but that's because we're carbon-based. And we have DNA, which depends on oxygen as well to survive and, of course, exist. So, that was actually the premise of the book I wrote, which was to really explain why studying the Earth and the biology here is so important, for instance, to be able to figure out how alien biology might work. And when people say, well, is carbon-based life all there is? I say, well, carbon-based life couldn't exist on this planet right here on the screen. The surface temperature on this planet's over 900 degrees. And the atmosphere is a whopping, oppressive 90 times the density of our own. So it's going to be a lot more mass down on your shoulders and hitting you on all sides, just like when you go in the water. As you dive deeper into water, you get squished from all sides. And really what you're feeling is the weight of the air over your head, which at the surface is about 14.7 pounds every square inch on your body, pressing every place on your body. But your body's evolved into that, so it can handle it. But on Venus, we're talking about crushing pressures that are much higher. And, that pressure is something that is, we would say anathema to human life. It's literally something that would not allow you to survive for more than a split second. I don't even know if you would have time to be conscious of what was happening if you suddenly got transported to Venus. You would just be crushed out of existence in a moment. So it's for our sister planet, as you called it last time, Daryl, for our sister planet, it's anything but our sister. It shares about the same size as the Earth. It doesn't share the same rotation rate. It doesn't share the same magnetic field properties. And those differences make a whopping difference in how Venus evolved.
She's the evil twin.
Yeah, right? Yeah. I think so.
Some people might find it interesting that you would think Mercury, being closest to the sun, would be the hottest, but Venus is actually hotter than Mercury. And that's because of that heavy atmosphere acting like a thermal blanket.
Yeah. Venus is actually just an impressive, oppressive planet. And I don't think that we would be ever trying to terraform or live on Venus. I just don't. There's really nothing there. It's actually better to start with nothing than to start with an atmosphere like Venus and try to whittle it away, because the technology to get rid of atmosphere is something we don't have, nor do we have a way to make an atmosphere. So we need to go someplace, for instance, where the atmosphere can make itself, if allowed to. And this goes to a project that's on the NASA books that Amanda loves. You do. And it has to do.
NASA books?
Yeah, it's on the NASA. It's on the NASA docket as a mission to Mars someday when we have the technology to actually terraform Mars. And you know exactly what I'm talking
My
about.
blanket.
Yes, it is.
Yes.
Yeah. So
May I say that the first case of possible terraforming I ever heard of was of Venus, very long time ago. I think I was still a kid. The idea was to seed the Venusian atmosphere with blue-green algae, and we're talking about a very long-term project, but that the blue-green algae would start changing the upper atmosphere of Venus and eventually make things more conducive to life for us.
oh yeah.
You know, you're talking really long term, but you know, hey, if you're a stable civilization, you know, you got time.
Yeah.
What happened with that project?
I'm sorry.
What happened with the project? Did any of it happen? Did it?
Oh no, it was just speculation. It was a proposal, I guess you'd say.
Oh.
Well, we
That sounds interesting. I mean, I don't know if it's possible, but I mean, I like the idea. See what happens.
sure.
Yeah.
But the chances of it working are directly dependent on the capability of the technology to deliver this algae to the upper atmosphere of Venus, and that is something we don't even have yet. So back when they thought about it, it's like, hey, if we can get this technology,
Sure.
yeah, but we can't yet. We're not able to do that. So right now, this planet, as tantalizingly big as it is in the screen and close as it's going to get, it's going to remain out of reach. We don't have a way to terraform this at this point. So hey, that's it. Now as far as Mars goes, however, Mars is farther out. It's just on the edge of the outer edge of the habitable zone for our sun. Venus is inside the inside edge. I'll say it this way: just outside the inside edge. So it's not quite in the habitable zone, although you can argue that it is, but it's still too close. But Mars, being just on that outer edge of the habitable zone, has some peculiar capabilities that we could take advantage of. And when Amanda said the blanket before, what was I talking about for that? Well, there's a project that NASA has on the books to actually take Mars and terraform it by letting Mars do the natural thing. Mars makes oxygen through geological processes, and it makes water vapor through geologic processes. So it's possible then that we should be able to take and let Mars just do its thing, and over time, the atmosphere will build up. Right now, it's like 0.08 of Earth. I mean, it's really, really small, minuscule atmosphere. In fact, it's essentially a vacuum as far as humans are concerned. But if we could somehow keep the ultraviolet light from the sun from destroying the water vapor molecules, the water molecules, H2O, that are made in the normal processes on Mars, then we would end up being able to retain the water. And if that were to happen, then the H2O that did get disassociated would end up when I say disassociated, it means the two H's, the hydrogens, get broken away from the oxygen. Okay, then those oxygens will be free, and they could go down in the ground and bind with iron compounds to form a rust, which is actually what happened to a lot of the oxygen on Mars. That's why it's red. And then we can also work out a way to make diatomic oxygen, that is O2, the thing we need. And if we can protect that molecule and not let the ultraviolet energy from the sun hit the planet's surface, sterilizing and ripping apart molecules, then we would be able to protect the Martian atmosphere and watch it grow on its own naturally. So how can we do that? Well, how did Earth do it? And Earth did it by itself because Earth has a magnetic field. And the magnetic field traps those high energy particles and prevents them from reaching the ground where they do damage and where they rip apart water molecules and where they rip apart O2 and other molecules in the atmosphere and make it impossible for the it would make it impossible if it hit the ground to make the oxygen and keep the oxygen in the atmosphere. It would be broken apart. So on Mars, it doesn't have a magnetic field. The core of Mars has cooled off enough so that any magnetic field has been reduced to ineffectual at best, so ineffective. Okay, request denied. No atmosphere for you. And over time, the atmosphere kind of bled out into space, and there were impacts that caused it to. But I think that the important thing here is if we could launch a mission that NASA has in the books to what's called a Lagrange point on this side of Mars, that is between the Sun and Mars, and that mission was to park an object, a spacecraft, or a device in that parking spot in space, which are what Lagrange points are, then if that could generate a big magnetic field, it could actually then be used to supplement and or become the Martian magnetic field, because when the sun's particles hit a magnetic field, it forces the magnetic field lines away and down, away from the direction of the sun. And so if the magnetic field is big enough, we could actually make the magnetic field drape around Mars like a blanket, as Amanda said. And this blanket would protect the Martian atmosphere, the tenuous infant Martian atmosphere. And then over time, it would grow to a much higher pressure, and we would see clouds on the surface of Mars. It might only take about 10 years before we see clouds on Mars. There's clouds now, but they're very, very thin. But we might see more substantial cloud cover on Mars. We might actually see water vapor in the atmosphere that makes substantial clouds and maybe eventually rain. And then the secret, standing water, ponds, lakes, puddles. That is something that the Blanket Project, it's not called the Blanket, but I just like Amanda's name for it. I thought that was a great name. So that might work, and
you must have described it to me once as a blanket, because I don't know where else I would have come up with that term on my own. I must have heard it referred to as a blanket somewhere, because that's what stuck.
Okay, well, fair enough, because it is kind of a blanket, isn't it? It's sort of like a security blanket for Mars.
We actually had a question about that. Well, kind of about that. From Steven, he says, isn't it true that Mars's mass is too low to retain its atmosphere, even if we were able to terraform it?
You know what? And the answer is no. There are certain... I'll tell you why. The moon is too small to retain an atmosphere, all right? However, the moon does have an atmosphere. I don't want to break it to you gently here, but that's all I can say. It does have an atmosphere, but it's extremely tenuous, and it's mostly sodium atoms. And it's not the atmosphere from the astronauts' backpacks and stuff like that. It's actually an original primordial smattering of atoms that managed to cling to the gravitational field of the moon. So Mars is big enough to retain an atmosphere. It has. It has carbon dioxide in it now, and it could handle and maintain holding on to oxygen if it was made. Now hydrogen would likely escape to space, but that happens here too. But more so on Mars. But that might not be a showstopper. Venus, on the other hand, this guy is just a nightmare, right? But as far as Mars size, yes, it's smaller than the Earth, but it's not small enough that it can't retain its atmosphere, because it used to have a much heavier atmosphere, in fact. And then once the magnetic field stopped, Mars had water on its surface. We know this. Mars had standing water, had lakes, rivers, perhaps even oceans. And we see the remnants of where this water ran on the surface. However, the problem is not that Mars is too little in mass, too low in mass. The problem is that the magnetic field was weakening over time, and eventually the sun's ultraviolet energy could split apart the H2O molecules, the water molecules in the atmosphere. The hydrogen would get lost to space. The oxygen went down into the ground and bonded with the iron compounds to make this rust I told you about, which is, like I said, why Mars is the red planet, because it's rusted. Kind of like the B-52s, Love Shack, the tin roof, rusted, So Mars has a unique opportunity to regain its atmosphere if we can just help it along. We don't even have to go to the planet. We just need to park a magnetic field generator on that place between the sun and Mars. That's like a parking spot in space, the Lagrange point. And if the sun's energy is worth its weight, and I'm sure it is, then those high energy protons and electrons, known as the solar wind, could push that magnetic field out from our generator, and it would drape around Mars, and it would then protect Mars from the particles trying to stream down to its surface, because they would get trapped in this artificial magnetic field. Now, here on Earth, the sun's particles get trapped in our magnetic field, and this is what we call the Van Allen radiation belts. They're one and the same. I wonder if you knew that. The radiation belts on Earth are the trapped particles from the sun in our magnetic field. If those particles got to the Earth, well, Earth would be sterile. There would be nothing growing here. There would be no ability for plants to grow here. Photosynthesis could not take place in earnest because of the fact that this radiation would have sterilized the soil and removed a lot of the nutrients that would be needed. So that's a kind of a long-winded discussion about the Mars blanket, but that is a project that could terraform Mars. We don't have one that can terraform Venus here. Okay.
I have a question, and there's an interesting conversation going on in chat right now too. The
Sure.
question's coming from Jensen. It may have already been answered, but I just want to have it confirmed.
Absolutely.
Jensen wants to know how long it would take a starship right now to get to Mars, and people are suggesting 6 months. Does that sound right?
It depends where. Yeah, and Daryl will agree. It depends where Mars is relative to the Earth. There is times where we're both on the same side of the sun. Okay. At those times, we're closest to Mars, but that's not when you launch. You launch before we're closest to Mars. And that way, when you actually get out to Mars, you launch the ship to where Mars will be when you head out there. Okay, so where you're going to point your ship is not where Mars is now, but where it's going to be. And where it's going to be is that point of closest approach where we might actually be able to get there in as little as, say, 6 months, 10 months. You could take anywhere from 4 minutes to 22 minutes to get a signal to Mars, depending on where with light, depending on where Mars is in its orbit.
Yeah, 'cause people are just talking about what that trip would be like if they'd want to be asleep through the whole thing, if they could make it, if they could be stuck inside a metal tube for 6 months. So.
Yeah, they have to be.
Sorry, Daryl, go on. What were you saying?
Well, I found out I had muted myself again for about the last 10 minutes, probably. I've been trying to jump in here all this time.
Oh, we'll go for it, man.
Well, no. Well, it may just be a misnomer, but calling it a starship. Okay, you don't need a starship to get to Mars. You just need a spaceship. I imagine if you really had a starship like the Enterprise, you could get to Mars in 10 seconds if you wanted to,
True.
Something that'd go that fast, but that's just silliness right there. Now, I want to go back to what you were talking about. I have a philosophical tack on terraforming.
Okay.
Would we have the right to terraform another planet?
That's a good question, Daryl. I agree with you, and that's a question that needs to be argued and discussed. I mean, how do we know that there isn't life on another planet, and how do we know that we won't force an entire species to go extinct because of our need to terraform a planet?
Yeah. Well, and I guess ultimately that would be the deciding factor. If Mars is truly dead, Is that the only thing that would keep us from terraforming it? That didn't come out right. Venus is probably much more likely to be a dead planet. So would we be free to do as we wish with an entire planet in any event?
Yeah.
Have we got the right? Are we playing God when we do that sort of thing? These are big questions. Mars, I know, the current thinking is Mars is much more likely to harbor life right now.
Yes.
And would we therefore not have the moral right to try to change it?
Yeah, I actually do deal with this problem a lot. I do think about this, and I wonder, again, talking about, here's another thing, going to an exoplanet around another star. Do we have a right to visit a planet around another star? Because our very presence could cause a tremendous effect on the indigenous inhabitants if there are indigenous, intellectually sound inhabitants. What would our presence do? What we would probably want to do is to be surreptitious and quiet about it, and study through blinds like we study elk. Not elk, bald eagles. We look at them through blinds that allow photographers and nature folks environmentalists to watch them without them knowing they're being watched. And if you think about it, isn't that really what the whole UFO movement's all about? The UFOs are here supposedly to, for whatever reasons are here, but if there are advanced aliens and advanced extraterrestrial life out there, and they come here, they're not just going to announce themselves and say, look at us, we're so much more than you. They're going to show up quietly and they're going to hide because we are dangerous. To any life form in the galaxy, we're probably dangerous in some way. We have enough technology that we could probably do some harm to most of the life forms that are out there. And so they would, if they were clever, and they are, because they go that far to get here, then they would know that in their quest to seek another planet that has an oxygen atmosphere, because they're carbon-based like us and know that oxygen signals life potentially, they would come here because we stand out like a beacon in the cosmos. And when they got here, they might notice that, we have things we drive around in. They wouldn't know their cars. They would just say that interesting, machinery or whatever. But then they would notice that we divide up our territory and we say, mine, stay out. They wouldn't look at us as a population ready to join the galactic trades. I mean, we are too busy fighting over each other and fighting with each other. And that's obvious from just observing. And they don't have to understand a bit of our language to see this or understand that. All they have to do is to be able to intercept a television signal. They would say, catch the prices right, and say, wow, this species is very competitive. And that right there it's obvious. You can actually figure out what's going on without even knowing the language. So I think that knowing all these things, they would probably be very careful about trying to contact us. And more specifically, they'd be very careful about which groups they would contact, if any. Because if you contact this one, well, because of the competitive nature of these beings here in this planet, then there's another group of beings that are probably going to get mad at these guys because we talked to them first. So that would tend to make me, as an explorer, think, let's not contact any of them. Let's just watch from a distance. Let's watch from a blind.
That's my I Love Lucy scenario. I've said before, if I was an alien species and I received old I Love Lucy reruns, I'd probably declare on the planet and come right first. Where? Ricky,
Babaloo. Oh my gosh. That's hilarious. That's really funny. Wow.
We have a few more questions coming in.
Okay.
I'm not sure if you're on the group chat in Skype or not, because every time I post it, I don't see your Skype lighting up. Usually I do.
Yeah.
Oh, okay. Weird.
So how come I didn't see it either?
I don't know. Usually, like, I can see your Skype light up when I post something, but that's okay.
Well, now
okay, I see them. Yeah, as long as you're getting them, that's fine.
Okay.
The next question was from Steven.
Okay.
And he said, could we then terraform Mars so that its atmosphere maintained the same pressure as Earth? Would that be the kind of atmospheric pressure that we would be aiming for at engineering for humans?
That's interesting. I think that at a minimum we would want to engineer it for humans to wear, if anything, a very, very lightweight and let's be fair, cheap exosuit, so that they wouldn't have to worry about the lack of pressure on Mars. It might be the pressure, say, of a mountaintop, like Mount Everest or something. That would be livable. It would be cold, but still, Mars is going to be cold. You're not going to have summer with 80 degrees on Mars unless you force it. And there are places on Mars that have gotten to like 70 degrees Fahrenheit, but usually those are in the deep valleys in direct sunlight at the height of the Martian summer and only for a few minutes. I mean, so we're not talking, we're talking a planet that's generally going to be colder overall. But I think that the kind of pressure you'd aim for is one where if you were without a pressure suit, it wouldn't kill you. But you would probably need some form of a cheap pressure suit to survive. And you're going to always probably need oxygen. Because I don't think that we're going to be able to make enough oxygen on the overall planet for us to survive. Not unless we come up with an entirely new scenario, kind of like Schwarzenegger did in Total Recall, which was kind of silly. If you remember that movie, they had to like these giant tubes, these giant rods had to be thrust into the core of Mars, and it made oxygen, and the entire planet was covered in oceans of oxygen, basically, in minutes. And the sky turned from red to blue, which is interesting because the reason it does that has nothing to do with the oxygen density per se. It actually has to do with the scattering of nitrogen and oxygen, which wouldn't have had nitrogen in the atmosphere. So it's just, I don't know, it's Hollywood, okay? But anyway, I think that we would probably be looking for a livable but not Earth-like conditions, because I think that's asking too much of Mars. That's just my thought.
I might see something like, maybe not on top of Everest conditions, because that is too thin to breathe, or without oxygen. But there are lots of people live up high in the Andes.
And that's true.
Do just fine with it. Instead of talking around 30,000 feet, if you're talking about 20,000 feet equivalent or 18,000 feet, people up there seem to get along okay.
Yeah. No.
You may see physiological changes in any colonists on Mars over time with that. You might tend to see people with big lungs or big chest cavities and stuff like that. But that's adapting to local conditions. Yeah,
and of course, this adaptation to these local conditions is something that every human would have to do if they went to Mars, right? Why do I have a black screen here? What am I doing here? Oh, I know what happened. Venus has gone behind the house. Oh, no. Yeah, it must have. Hold on. This is an old picture. Let me tell it to do it again. It'll be darker now. Yeah, just a little darker. Okay, let me bring us back here. Bring up our level here, because I want to show you what we're looking at. Okay, now what I'm going to do is take and make the picture that I'm going to take is going to be a lot longer. It's not 3 seconds, but it's going to be 40 seconds.
Mark, could you please put your chat back on chat?
Oh, sorry. Yeah, I was actually just wanted to say hello to Amonarel, Brandon Thomas, Charles Smar, Daniel Whitaker is here. David Schmidt. Hey, David. How's Bangkok going? And, of course, Amanda. And Dew is here. Jensen H. and Kathleen Solway Kessel is here. And Katie Q. and Lori Arwith. I think it's Arbonat. I can't tell. And then Rockstar is here. And, of course, Daisy and Zoe are here as well. And Daisy and Zoe have a special guest tonight named Lainey. I just wanted to welcome Lainey to the SkyTour LiveStream, and I'm very, very happy to have you here. And now I brought the chat back for Daryl. Amanda, I'm sorry, do we have more questions?
We do. Sorry, my mouse has been sticking lately. Let me flip back here. The next question is from Eugene. He said, years ago I watched a show where they were generating intensive magnetic fields with rotating molten sodium. Would that work for a planetary shield?
Oof.
Not sure if you're familiar with that idea or not, if that makes sense to you or not. Or
I remember there was a generator, a magnetic generator. I don't remember whether it was molten sodium, but yeah, for sure that let's say it did work. Think of it at the planetary scale. At the planetary scale, you have a better chance of remelting the core of Mars. Because there's a lot to happen. A lot has to happen for that magnetic field to get restarted. So that's why it's best to make this artificial magnetic field, this blanket, this drape that drapes around Mars and protects this atmosphere as it grows again. And in chat, DewW actually says something that's very prescient, very right, and very correct. And he says, wouldn't the carbon dioxide in the atmosphere cause the atmosphere to heat up? Yes, you do get a greenhouse effect, of course. And that's very important. But when an atmosphere heats up, it also expands. And that has to be carefully managed because an expanding atmosphere that's getting warmer could, bleed off some of its mass into space. And you don't want that. So you have to have sort of like the right amount and the right stratification, layers, that is, of components in an atmosphere. We're talking, it's literally best if we let Mars do what we know it can do. But the CO2 is mostly what is in the Martian atmosphere now. And over time, and that's because, of course, the oxygen and was fragile, tied in with H2O. And that's not the only source of oxygen there. But the oxygen was leached out, and then it ended up going into the crust and bonding with rocks and so forth and make rust and other compounds. So the best thing is to stop that ultraviolet light from getting to the planet's surface. And Mars will naturally do what Mars will do. Its atmosphere will grow. And right now, Mars is in a strange equilibrium. It's in an equilibrium that keeps its surface at a certain pressure and no higher, because if it gets higher, then you could have, it's literally right at that point where just a little bit higher in some places you can have liquid water on the surface. You would say, well, wait a minute, that seems like it's almost planned. It's not. It's actually the way these systems work. It's a normal process. So Mars actually basically loses some pressure to get to a certain point, and then it's stabilized. That stable point happens to be where it is now, where the atmosphere is very, very thin, and water can't exist for very long. We know that water does rush out on Mars in some places, but it's immediately evaporated and sublimated away to water vapor. And that's like in the sides of craters, where the crater's gouged deep into the ground, and the edge of the crater is I'm going to instruct the telescope to move while we're here. The edge of the crater is far down into the ground. So technically what you'll get is that the crater wall might be the equivalent of, say, 200 feet down or 500 feet down or half a mile down. And so under pressure in layers beneath the ground of Mars, there might be water running. We know there is, actually. And sometimes it can burst through those crater walls. And when it breaks through those crater walls, it can flow and tumble down inside the crater, and then it sublimates away and goes away. Because
this is where they see the dark streaks coming down the crater walls, right? And they're evanescent. They don't stick around.
Yeah.
Because the water comes out and it evaporates.
Yep.
I know they have a lot of Martian images of that.
Yep. The dark gullies and stuff. I think I got to go move the telescope, guys. So I'm sure that everybody would just be happy to take a break from hearing me just going on and on here. Let me just go move the telescope to where it needs to go so that we can look at the comet, all right? So Daryl and Amanda, I'll be right back.
Okay.
All right.
How you doing, Amanda?
I'm all right. How are you?
Oh, I have my ups and downs still. I'm okay. I'm sorry, you were about to say something.
No, there were a few questions that were coming in, but there's one you can probably answer because it actually came up yesterday in chat. We didn't really get to talk too much about it, though, and I wanted to know the details. Lori had asked, what about the Atlas Comet? And you said that it is actually broken apart now.
Well,
that's official.
Yeah. I mean, they've known it's official for a while. Yes, the comet, the nucleus has fragmented. It is still more or less hanging together, but it is slowly disintegrating, and it's getting dimmer, which means it's basically breaking up. I mean, the Comet Atlas is a going thing. Well, it's on its way out.
That's too bad. I know there's a lot of hope that it was going to make it around the sun and we were going to be able to see it, but...
Oh, sure. But hey, that's the way the cookie crumbles, literally.
Yeah.
And it's
so I guess we won't be able to see it tonight then. Like, is there anything left to see? Is it too dim to track now, or?
Well, I guess we're going to find out when Mark comes back.
Oh, I think I see him now.
Yeah. It is still loosely hanging around, okay? The pieces of the nucleus, though they're getting farther apart, and it's sort of basically dissolving up there in the vacuum of space now.
You talking about the comet?
I bet we will see something tonight, though. It's not going to look like it did a couple of weeks ago.
No.
That's going to be interesting, too, because we have pictures from last week when it was, I guess it was still fragmented at that time, but, it'll be interesting to compare how much disintegration has been done since last time we saw it.
Yeah, I suspect we're about to find out.
Yeah, I think so. I'm just going to redirect the scope to a star and then have it go back to the comet. Thank you.
And I wanted to mention that because Daryl had mentioned that yesterday, so I jumped ahead a few questions, but we do have a lot more coming in.
Okay, cool.
While you look for the comet, shall we take one?
Sure, please do. Thank you.
Okay, Rockstar wants to know, if a meteor hit Mars, could it terraform Mars?
Hey, that's actually a really good question, Rock. And I'll tell you why. Because if a meteor was to strike the planet Mars, it's going to bring with it a certain amount of material. Now, we know that meteors that have struck the Earth have brought organic material, or a semblance of organic material, the building blocks, amino acids. So we know that probably happened on Mars as well. Okay, so if it happened on Mars, if it happened here, it could happen on Mars. Now, what happens to those materials afterwards, though? That's the key thing. Now, would those things actually be surviving and survivable? Would it be a survivable environment? We don't know. We don't know. Maybe it is, maybe it's not. But I do know that if we talk about terraforming, well, terraforming is a process that takes a long time. An impact event that occurs on Mars would actually be something that would probably do more destruction to Mars than anything else. Okay. Oh, look, that's Capella. See? This telescope's using Capella to line up on right there before it rushes off to find.
Capella the goat herder?
Yes. Before it yeah, see, look. Before it rushes off to find. See? There's Auriga. And
if I hear things often enough, I tend to be able to repeat them, but
yeah.
I have to hear them an awful lot.
Yep.
And I was a little nervous about guessing at that one because I'm like, is he actually the goat herder or is he the goat itself?
Nah, you got it.
Who else am I thinking of, Daryl? There's the goat herder and there's
Booties.
Capella, Bootes is the herdsman. Okay, Capella is the goat star. But Capella is in the constellation Auriga, which is the charioteer.
Okay, I was thinking there was a chariot in there.
Capella, they call it the goat star. God knows why. I forget the story. But Auriga is holding 2 or 3 little baby goats in the crook of his left arm. And maybe that's why they call it the goat star.
Interesting.
That's cute. I'd like to be holding a bunch of baby goats.
Yeah, if you ever see a good constellation chart for Auriga, the charioteer, the baby goats are called the kids, and
That's
it's
right.
a little triangle of stars just close to Capella.
Cute.
It's Capella and the kids.
Yep, Capella and the kids.
That's what we talk about. Capella and the kids. All right, we're going to do a 20-second finder shot at 32,000 just to see where we are. We're going to see all new stars tonight for where the comet is, because the comet is going to be against a different background of stars. It's moving very quickly. So let's put Venus in its proper location, and it will be replaced here by hopefully the comet. Let's see.
Just on that last note, is Capella a double star?
Oh, there it is. Is Capella a double?
I would have to look that one up. I believe Capella, it may be a multiple star. A double, I'm not sure. Epsilon Lyrae.
Double means coffee with 2 cream and 2 sugar to me. It's a Tim Hortons term down here in Canada.
Well, Epsilon Lyrae is a double.
Yes, Epsilon Lyrae is the double.
Yeah,
that's one of its popular names.
And Capella's a double star anyway. So at least a double star. I don't know if there's another spectroscopic component in there somewhere. Maybe there is. I don't know.
Yeah, I'd have to look that up myself.
Well, we did this white light shot, by the way, just so you know, and you can see the remnant of the comet here. We'll do another shot of it with a filter. Go ahead, Daryl. Go ahead. Sorry.
Well, to go a little farther with what Amanda was asking, we mentioned Bootes a minute ago, constellation of the herdsman, which is rising right now in the over in the east-northeast, probably from your location.
Yep.
Arcturus is the brightest star in Bootes. It's actually just a shade brighter than Vega is in Lyra. And that's the herdsman. It looks like a long, narrow kite shape up in the eastern sky right now.
Yeah.
And that's the one, if you follow the curve of the handle of the Big Dipper, you arc to Arcturus, and then you speed on to Spica, Spica and Virgo, to kind of string them all together. That's how you find them. Anyway, that's all I got. There's a comet.
Mm-hmm.
And it sure is diffuse looking now, isn't it?
It is. And there's a star in the middle, so don't confuse that as part of the nucleus. But there's a little star right there. And you can see the nucleus is distended right here. Hey, let's go look at this in the filter, shall we? So we're going to go back to our view here. And for those that know what we do, you can follow along. Telescope control system is here, and then down here we have a filter wheel. Right now we're on filter 5, which is a no filter. There's nothing in the way. It's a 2-inch round hole through which the camera is looking. But if I come back one, we're going to go to 4 and then 3, which is the spectral system, which you can see the spectra of some of the stars showing up here. We're going to be doing more of that with a new spectrometer system that's going to be arriving any day now, let's hope. And we're going to look at it with 2 here. The filter 2 is a narrowband filter, but it's a little bit of a broader narrowband filter. And this narrowband filter is kind of what we're going to shoot with, because the other filter is the filter number 1, and that is a strict narrowband filter. It's very, very fine passes through the spectrum of only specific frequencies. Okay, well, notice you see no stars. Okay, that's because it's trying to pass only certain frequencies through. This filter is a little more forgiving, and it has more data. When we changed to this filter, it was like night and day. And when we go to 1, the other filter I just showed you, it's going to be like between, it's going to be even more stunning. Let's put it that way. I took some shots at the Orion Nebula before it set with that in one stream, and you could see the intricate details in just a few second shot. All right, let's drop this down, the ISO. We're going to drop it down. Let me just go back to our view here. We're going to move, actually, I'm going to take that star and I'm going to move it a little more to the right. So we want to bring the comet in more into the view. Okay, there it is. And then we're going to drop it down into the view a little bit. I think that is probably too much. Let me see. Go up a little more. A little bit. Okay, now the comet is going to be right about here. Okay. So, we'll go to 12,800 for, let's say, 25 seconds, shall we? And see what the comet looks like now. And we're off. And how's our night sky looking? Oh yeah, there's our stars. You can see the beautiful starry sky. Not bad though, huh? Okay, now here's the Big Dipper right here. Okay, and there's the tail of the Big Dipper. Here's the bowl of the Big Dipper, and those 2 end stars point to the North Star. Here's the Little Dipper, you can see it. And where we are is... Okay, this is good. All right, and I'll show you again. Where we are looking over here. Somewhere in this region right here. Which is where the comet is. All right. All right, so yeah, so here's the comet now. Let's take a look at it. Well, you can see pretty clearly now. You can see pretty clearly that it's actually got a fairly wide coma here. What we call a coma. You see that, Daryl? It's actually looking like it's got some wide, diffuse nature here.
Yeah, it looks very elongated to me.
Yeah, and well, certainly it is.
Rockstar wants to know how fragmented it is.
I think there's right now, as far as some of the high resolution imagery that I saw, I've seen 3 distinct fragments so far, but that was as of like yesterday morning. And maybe there's more. I'm not sure, but there's 3 distinct fragments right now that I remember. Have you seen any other thing other than that, Daryl?
I haven't looked for the last couple of days, frankly. The last I saw, I wanted to say there were like 2 pairs of fragments that, sort of like a double-double.
Okay.
I could be wrong about that. Don't quote me.
No, that's all right. I mean, you could be right too. I just remember seeing 3 distinct pieces, and I'm not sure if one of those pieces might have been more than one piece. Could have been. So we're going to go back to the. I'm going to go back to this screen, and we're going to actually go up to 1 minute. on these photos. Okay, and we're going to take another one. So I want to try and pull out any more detail that's in here if I could. And we're using the narrowband filter, which is excellent for showcasing nebulae and other things like comets as well. And you saw that green color. That green color is really, really stunning. That's the carbon atoms that are being ionized in the halo of this comet, the coma we call it. You're getting, carbon-carbon molecules, which are what we call C2. So 2 carbons bonded to each other. We're getting carbon with nitrogen, which is cyanogen. We're getting carbon monoxide, which is carbon, and then monoxide, or one oxygen, so CO. And we're seeing that. And when those carbon atoms get ionized, when the electrons jump back into the atom, they give off. That's just beautiful. They give off a green glow, which we clearly see here. That's actually pretty nice. Let's zoom in a bit and see if there's anything we can see that might give it away. And the answer is not really. I do see that we have some interesting features going on.
Question for you guys.
Okay.
Is there any kind of site or anything that would give people like directions or instructions on how to see the Lyrids shower based on their location in the globe? Because David's saying I posted something yesterday, but I thought I just Googled something on how to see it from South Africa. But I thought everybody was just supposed to be looking east. And depending on how west you were, the further down in the horizon it would be.
Well, it's only going to matter. Your latitude matters, okay, where you are on the Earth. It's always going to be toward the northeast at a certain time of the night, depending on the time. Later on after midnight now, if you're at around 40 degrees latitude north, okay? If you're not at 40 degrees latitude north, well, then it's going to be a different direction you're going to look. And if you're down near the equator, for instance, it's not going to be toward the east as much as it'll be more toward the north.
Are there any places where you can go and type in your location and it'll kind of calculate where you should look?
Yep.
Where?
Well, I always use Heavens Above.
Yeah, Heavens Above is good, yeah.
Sometimes. Heavens Above will give you a simple... I'm having a brain lock here. It will give you a simple planispheric map of the night sky. You have to plug in your location up in the top right-hand corner, find your location first. And they haven't made it easy, but once you find that, you can save it. But to save it now, you have to enter a certain 3-word phrase that they will give you. It's kind of silly. You have to jump through a hoop to be able to save it. But anyway... go to Heavens Above. It's heavens-above.com. It will look for location up in the top right-hand corner. Plug in your location and follow the instructions to save it to your favorites, to your bookmarks. Mm-hmm. And in future, it will always be there for future reference. Your location already plugged in. Then all you have to do is look for Vega and the constellation Lyra. Which, from South Africa is going to be, I would think you'd be able to see Lyra from down there, but it's going to be way up in the northeastern sky.
Yeah.
Well, actually, David was asking, so we're looking for Thailand. It's just I know a lot of
Bangkok.
people came into Bill's chat yesterday from South America. So that's the only link I can remember posting yesterday.
Yeah. Okay. I saw that with David. Sorry, David. Thailand isn't nearly as far south as South Africa is, of course, so Lyra should be somewhat farther south, higher up, that is, in the sky for you. But you'll still have to be looking in a generally northeasterly direction.
Yeah, well, even I do here at 40 degrees latitude. And Bangkok is still north of the equator, so he still has, I think it is, right?
Close.
Yeah, it's actually, I think, somewhat south of Bangkok. But still, you know,
well, I hope that helps you, David, and anyone else that wants to check it out. I mean, it's a wonderful tool to have anyway. I think Daryl uses it at least once a day, every day.
Yeah.
I do.
Often.
It will also let you. It will show you Starlink satellite train passes. It'll show you International Space Station passes, all sorts of stuff.
Yeah, it's a really good site. Really, really good site.
It's very simple, and it does all the calculation on its end, so it doesn't tie up computer resources. But it's a simple planispheric sky chart. It will show you.
Yeah. Very nice.
I like to keep it simple. I mean, and if you feel like you want more than Heavens Above can, well, Mark likes Stellarium.
Yeah.
You can download that and run it on your computer, plug your location into it, and it'll show you a whole lot more than Heavens Above ever will. But it may not be as easy to understand for a newcomer, which is one reason I like the simplicity of a Heavens Above.
Yeah. Yeah. David is no longer in Bangkok, by the way. He's with his family now. And is it Khon Kaen, Dave? I don't know how you pronounce that. But it's one of the there's like 4 big cities, I think, and this is one of them. So I believe that's where he is. Smaller than Bangkok, much more manageable. Excellent. Well, hey.
We still have lots of questions.
Please go.
And they're going back to where we were talking about terraforming Mars so.
That's okay. Go for it. I'll continue to take pictures here.
If the conspiracy folks are right, and it was aliens who intervened with our planet to give us a jump start, wouldn't it translate to us having the same right to land on another planet? I said no, but I said I would also get your opinion, Mark and Daryl. What do you guys think of that statement?
Okay. Well, Are we doing the same thing, basically? See, Daryl, I think that's what the question is, right? Are we doing the same thing?
Exactly.
Yeah.
And if there's already...
Sorry, go ahead.
As to be good stewards of life, if there's already life there, that's the philosophical question. Do we have the right to mess with it?
Right.
Should we leave it alone and let it develop on its own? Will we destroy what's already there if we try to improve it for ourselves?
And do we have a right to do that,
Exactly.
Yeah, these are philosophical questions that are tough to answer, because we've never encountered other life somewhere else.
No, I mean, even, they're saying, if aliens created us, I mean, you could use the same thing for religion. If a god created us, I mean, if anything created us, why would that give us the right to do it to anyone else?
True.
That's where I'm coming from, but,
yep.
It'd be, interesting to see what happens, but then, I mean, isn't that kind of the same thing, we're dealing with, maybe not artificial intelligence, but I mean, how can you give something a conscience and then be able to just turn it on and off? Okay, maybe that's a little too far out there, but you know what I mean?
I do. I understand where you're going, and I think that in some ways, I think that that's correct. I think that, first of all, do we have a right to do it? Depends on your point of view. If we look at the solar system and say this is our solar system, then we can always convince ourselves that we have a right to do it. But do we actually have a right to do it? That's the question. And
I mean, personally, I don't think we should be testing things on animals or, killing animals for our own food. That's how I feel. So, I mean, and we're still doing that here on Earth to our own,
Yeah, I mean,
if it's alive and it has its own consciousness, I believe it has emotions and feelings, maybe not that we can understand, maybe not comparable to how we feel, but I don't know. I think it's wrong on so many levels, so this kind of fits in with that on my end, in my opinion.
Well, again, it's good stewardship, God knows we do not have a good record as far as being nice to other life here on Earth.
Not even other humans.
Yeah, we have purposely or through neglect, we have wiped out a lot of other species on this planet.
Yeah, we have.
We don't have a very good track record in that regard. So, should we, could we, can we, if we do go to other planets, can we be better stewards there than we have been here?
That's the question. That is the question. Okay, I did a lower ISO shot here, but I noticed that I have a focus issue, which I forgot to change. So we're gonna go focus this again. Whenever you have whenever you have different filters, many times you actually have to then focus over again, because the filters are a little bit different, and so you have to account for that. You have to make sure that you can take care of getting the focus right, because you're looking through different types of glass, different densities, and it will cause the focus to be a little bit off. So I'm going to go to the focus mode here, and I'm going to focus us right here in just a second. So I'm gonna get a star in here to.
Another question, maybe.
Yeah, sure. Go ahead.
Hold on. I'm trying to figure out where we left off.
Okay.
Okay, I don't know if we've asked this one. Jensen wants to know. I know it sounds sci-fi-ish, but literally, what if the indigenous life actually was aggressive? Say, if it was underground, what would we do then?
Oh golly, we've talked. Mark, you know where I'm going with this.
Yeah, we've talked about this.
Guess, yeah, it's the Horta from Star Trek,
yeah.
No Kill Eye and all that stuff. But
cry for the children in the halls of tomorrow.
Yeah, was it really being aggressive? Or was it just protecting its young?
That's right.
That's what if. What can I say?
Yeah, I mean, clearly, we have a right to the universe, a right to go out into the universe, but do we have a right to do anything we want at will with the universe? And the answer, I think, is a resounding no. We don't have a right to do anything we want. We have to take carefully metered steps. It's the mark, I think, of a young civilization that's going to make its way into the galactic community. I say galactic community because I tend to hope that we will, in fact, be able to make our way into the galactic community at some point. Because I do think that there's other life out there. I've told the story a million times. I won't do it again tonight, but basically saying that I said to my astronomy director of our observatory when I was getting my degree, I said to him, I believe there's life out there, and he absolutely was adamant that there was no proof, and he wasn't going to even field the question, basically. And then, of course, he argued with me a little bit about, how would I possibly know, blah, blah, blah. Well, again, it comes down to the same thing. Life here on this planet.
Oh, can I say it?
Yes, go ahead.
Did you tell him that you believed that it was a populated universe?
I did.
Ah!
I did.
And for
indeed.
those of you in the know, you'll know that's the name of his new book, The Populated Universe.
Well, yeah,
Available now on Amazon.
That was something that was very meaningful to me. I felt that.
It stuck after all this time.
Yeah. And it ended up becoming the book's title. So, but it's not just a phrase; it's actually a conviction, more so. And maybe I should be committed for all this, But the truth is, I think that the universe is full of life, because, and again, everywhere we look, guys. Okay, all of you listening in chat and all of you watching and lurking but not typing in chat, okay? Everywhere we look in the universe, we see the building blocks of life. It's right here in this comet. We're looking at it right here. This comet has carbon-based compounds in there that are complex carbon compounds, all right? All of which have gone into making what you are made of. Okay? What you are made of comes from comets, things like this. This is the real thing. This is the real McCoy. This is no, fake CG or anything like this. This is the real thing. And, over tonight, we're going to actually watch it move against the stars. From the earlier shots we took, we might even be able to see it now. Okay, there's an earlier shot of it. Let's take a look at the next shot. See if we can have seen it move. It's moving through these two stars. Well, yeah, look. There's those two stars now, right? And not enough time. Give us more time. A few more minutes, and you'll actually see this thing moving against the stars. So that's pretty cool. But yes, the building blocks of life are inside comets as well. And they're a template provided by the universe, So clearly, there's more life that is made of carbon out there because the universe provides for that template. That is the most important point. If you get nothing else out of this, then, get that, okay?
And Pete just dropped by and hasn't been around for a while. He wants to know if you're enjoying your new setup.
Oh, yeah. Hey, sure I am. How you doing, Pete? Yeah. No, we're having a good time. I mean, the new setup here, this is, we're using the Connecticut Observatory with the Arizona telescope in it because we're doing all kinds of testing and stuff. And no one gets to see the behind-the-scenes stuff that's happening because I'm just, there's so much going on. I talked today with Marianne, who's actually helping to orchestrate getting the observatory building built out there, and we're moving along for hopefully a June 24th build in the desert of the new observatory. And by the end of my time out there, which will be June 22nd to like the 28th or so, we'll have a building out there. We'll have the telescope building constructed, the observatory. Hey, Farva, thanks. Thank you very much.
Thank you, Farva.
Yeah.
Thank you, Cindy.
Oh, yeah, thank you, Cindy. I couldn't see you didn't see your comment about the blue. Thank you, guys. Thank you very much.
And I think we're still talking about terraforming Mars.
Yeah.
Du wants to know, wouldn't CO2 raise the temperature?
Oh, yeah, I did.
Did we talk about that?
I grabbed this question out of the chat, but I didn't do it in order, so I apologize.
Okay, no problem.
So why not make sure that I didn't do it out of order? So go right ahead and go.
Okay, then I think the next one would be another one from Steven.
Okay.
And I'm not, again, this is going back a bit, so I'm not sure what context this is in. Again, I think it's for terraforming Mars. It says, however, wouldn't we need as much oxygen as nitrogen in Mars's atmosphere? Would we, if we're going by Earth standards? Don't we need more nitrogen than oxygen?
Yes, we do. We can't breathe pure oxygen because pure oxygen, if we breathe pure oxygen, this is one of the early problems that, when they put infants in, oxygen tents, okay, and they gave them pure oxygen, for a period of time, that's okay, but the oxygen is really harmful. It's oxidizing. It's damaging the lungs. So we have to mix it with some other kind of inert gas. And nitrogen is very essential to our life processes, so it would probably have to be nitrogen. So we couldn't make it an oxygen-argon atmosphere, for instance. We might be able to breathe it, but it would actually... I wonder what that would do to our biology long term. Oh, man. That sounds like a science fiction book, guys. One of you out there, start thinking of it. Good night, Marianne. Marianne is heading to bed.
Night, Marianne.
Yeah.
What, argon?
Yeah, I'd like to have an argon-oxygen atmosphere. Because argon is inert. It won't hurt our tissues. But nitrogen, remember, divers who do deep dives, they can end up with nitrogen narcosis and so forth and get the bubbles in their bloodstream.
That's what I was thinking, the bends, yeah.
Yeah, so you get the same thing from argon. I imagine you probably would, but argon is a different atomic weight, a different element altogether. It's heavier. So what would happen? I wonder.
It's a noble gas. It doesn't interact with anything, really.
Mm-hmm.
What makes it good is a welding shielding gas.
Yeah, that's very true.
Would you folks excuse me for a moment, please?
Sure, go right ahead.
Thank you.
Oh, look at that. We caught an object here. A satellite on the all sky.
I was gonna say, is that a satellite? It looks like it went awful fast.
Well, that's because it took the old picture and then put the new picture up. I'd have to explain about screen buffers. You were just seeing the old image that was on the screen, or in the screen here, the buffer that's holding these images, and then you saw the latest image. Okay, the next one, if this is a satellite, it should continue from here and go this way or fade out at some point. So let's see what it does. We're almost there. We're taking another picture anyway. Yeah, see, it's a satellite.
Wow.
See? So it started from here.
I know if it was a shooter,
no, it would
have been going so much faster we wouldn't have caught it, or would we just have seen like dots, kind of dashes across the sky? No.
You'd see one flash. You'd see one thing. It might get bright a little bit. Because remember, it's a time exposure, so we'd see the whole thing. And it would only be on one frame, and it would be somewhat short. Unless it was actually a meteor that went across the entire sky, in which case it could potentially show up on two, but it would literally go across the entire screen. Because based on this, what you're seeing here, this is a slow satellite moving through the sky. See, there it goes now. Okay, and I know it looks curved, but it's not. It's moving in a straight path relative to how we're viewing it, but it's moving in a curved orbit around the Earth. Okay, so this is kind of neat. So you saw it here, here, and here. Now, every 45 seconds, a photo is taken, but there's no delay in between. So they're literally, they're literally, you can put them right together and string them together. So that's pretty cool. Neat. All right, so let me see how our picture came out. Oh, look at that. That's a very interesting photo. Okay. I did a minute and a half on the comet here. And when you move the comet, see what you can actually see the tail better when you're moving it around. See that? See how the tail actually goes out here?
I do.
You can see that. Yeah. And there seems to be some kind of details in this tail. The other night, I took a series of successive images of the comet. And it was really interesting because the images didn't show anything in particular, but you could actually, when I stacked them, you actually saw a more, what we call saturated, as in more color than you see here. It was actually pretty cool. Let me just check.
Have you taken the spectrum of the comet yet?
No, but the system I'm waiting for to come in is one that's going to allow me to do that. Yeah, I'm going to drop. This was at 32,000. I'm going to drop this down.
If it comes in soon enough, so we still have something to image.
Yeah, but I still have to get it running and make it work and tie it into the system.
You had one.
Oh, no, I do, and it's in there now. But it wouldn't show the spectrum of the comet in the way we need to see it. There's something called a slit spectrograph, and that's what I have coming. And what does that mean? A slit spectrograph is one that, for instance, it just takes a slice of light. Okay, like if I use the one that's in the system now, it takes this entire comet and makes an entire spectrum with a bunch of colors that you can't really identify where they are in the spectrum. It's a sort of a broad spectrum. But the slit spectrograph is going to give us specific things. For instance, we'll see a green line, a bright emission line right where this green is. All right, because we would be able to then identify what that's coming from. We could specifically identify the carbon compound that's making that line with what's coming in the mail when I get it. So I have to, it has a fiber optic system that goes and links into the telescope eyepiece, and I have to figure out how to get that in there. It's not made for my telescope. I'm going to make it fit. I'm going to make it work. Yeehaw. Gotta love engineering. You know? Sorry, go ahead if you have more questions.
We do have more questions. There's one that came in for all three of us, actually. I'm waiting until Daryl gets back. I don't even understand the question, so I don't know what my opinion is going to be yet. I think I'll go last. But right now we have, let's see the next one. A monorail says, using nucleus to produce an engine possible. Is that possible? Using nucleus to produce an engine?
Use the nucleus of the comet?
I'm not sure.
Use nucleus to produce a monorail. I'm trying to figure out what you mean. Use the nucleus of the comet to make an engine. Okay. I don't know if this is right, Monorail. You can tell me. I'm going to adjust my my pop filter here on the mic. Sorry for the noise. Comets are made of this icy material in their core, and the nucleus of the comet is really kind of this icy conglomerate of very, very ancient materials. And when they were formed, they trapped other molecules of gas and so forth inside of them, including hydrogen gas, maybe some carbon dioxide, methane. And when they begin to melt, from the sun's energy striking them, sometimes those pockets of gas get exposed, and the gas just shoots out at high pressure because now it's liberated out into the vacuum of space around the comet. Doing so, it shoots particles out, including other carbon atoms, which is part of the reason we see the coma. This outgassing, it's called, of materials happens all over the comet. We saw that with Comet Churyumov-Gerasimenko, which was 67P, which the Rosetta mission and the Philae lander attempted to land on. And so that process of outgassing is nothing we can really harness. But like, say you harnessed a comet and attached it to your spacecraft, could it propel you? Well, it would just as soon propel you in one direction as another, because you wouldn't be able to really steer it. Because this outgassing could occur anywhere on the comet. You don't know where it's going to happen. It might cause the spaceship to spin wildly in one direction and then go the other way. I mean, it would be kind of crazy, you know. So yeah, I think it's pretty crazy, you know. Well, it's a good question. I think that's what you mean. I'm not sure, but please, Monorail, tell me if I got that right or not, will you? Okay, Amanda, go ahead.
Okay, the next one. Okay, Pete wants to know, wouldn't an Earth-like planet with a lot more oxygen make larger life, or make life larger?
And very good, Pete. I mean, it's taking a lesson from history. You know, we definitely know that more oxygen on the planet sparks much bigger life, because life, uses this oxygen to create energy. And if you have a lot of oxygen, you don't need too much of it then to create an awful lot of energy. And if you have a lot of energy, you can create larger life forms. You can be a larger life form. So obviously, back at the time when insects first started showing up, they were huge. I mean, dragonflies, regular little dragonflies, which are so cute at 2 inches in wingspan, 3-inch wingspans now, the biggest ones. Wow, that's a huge dragonfly. Not compared to the ones from, about 100 million years ago. Those had 4-foot wingspans. Insects with 4-foot wingspans. I mean, these could truly, grab your head and twist it off the top of your shoulders if it wanted to. Okay, these were monstrous, tremendous creatures back then. But they were still insects. And you say, well, it's just an insect. Step on it. Good luck. It'll step back, But so, yes, more oxygen begets larger animals. Absolutely correct. By the way, I just want to throw this in. The comet is currently at magnitude 9.2 and getting a little fainter, I believe. You back there?
Anonymous had asked that what the brightness level was. Rock wants to know where it is right now.
Oh, I can show you exactly where it is. Is it in Camelopardalis now, or is it in Ursa Major still?
It's in Camelopardalis.
Yeah, I think it is. Yeah. And what does that mean? I'll show you what it means. Here's our finder chart. If we look, okay, this here, all right, we're looking at, okay, if we look at our mythology, okay, you can see the constellation of the giraffe, which is Camelopardalis, okay, and you can see the comet is here, all right, and we also have,
that's links.
Yeah, links, but let me do the boundaries so we can say this for sure. Okay. All right, now when we put in the constellation boundaries, you can see it's in this constellation bounded here, and that is Camelopardalis, right here. Okay, the constellation of the giraffe. So that's where it is, and it's eventually going to leave the sky as it makes its way toward the sun, which means it's going to become a daytime object for a period of time. Although we may not see it, obviously. But we will see it when it comes out the other side, potentially. But I don't know if any of you are going to be awake for that. Because I think we're talking early morning. Because when it gets to the other side of the sun, I mean, it's going to be an early morning object. So,
are you going to try to ever capture that, or?
If it still exists, I will make sure we capture it, yes.
Yeah? Okay.
Sure.
I mean, you're not holding out much hope that it's going to make it, though.
It's already fragmented, so those fragments are going to get, if anything, a lot smaller. But I was showing them before, Daryl, I mean, when you had to go for a second. When you move this around, you can see the tail of the comet pretty clearly. It's another way to show people that how the comet tail extends out to here.
Yep.
You can clearly see it. But what's clearly missing, however, is the other tail that we talk about so much. Okay, I don't see so much of a dust tail. Okay, this here might be the remnant of what's left of an ion tail. So I'm not sure how much is actually being, how many particles are being shed by this comet. Because when you move it around, you can actually see that straight tail. Dust tails tend to become like fans, you know, they'll be like beautiful little fans as the comet curves in its trajectory. But this one's kind of, this comet tail wouldn't look curved to us from Earth right now. Depends on the trajectory around the sun. So as it makes its way around the sun, then perhaps we'll see a little bit of a curve on the way out, perhaps. But on the way in, we might not see a curve because of our position in our orbit and so forth. But I just think that it's pretty cool being able to see it like this at all. This was a 1.5-minute exposure, guys. And I believe I took this at 32,000. And now I wanted to do one at 10,000. Actually, I'm not going to do it at 10,000. I want to do one at 3,200 because I'd like to capture just enough of the comet to be able to see if we can see any of the fragmented nucleus. Because what I did was I refocused, if you remember, and it looks like that focus has worked. So I want to see what it's going to take to see any of this nucleus if I can. I mean, they're really small objects, and I'm not sure if the telescope's resolution is even enough to see those. But we'll find out. So we're doing a 1.5 minutes now on the comet, but only at 3200 ISO. So that means instead of using 12,800 ISO or 20,000 ISO, the resulting image is going to have a lot less of this noisiness in it than we see here. This is 10,000. You know. Got any more questions, Amanda?
We do. I'm just trying to figure out what Flames of War is looking at. He's saying there's an orange one and a piece of another at the top, talking about red and orange stars above the comet. I'm wondering if he's actually seeing stars or if they're like maybe pixelations. Like I see a bright one kind of under the time, under the seconds.
Oh, there's one right here. Yeah. That's
your filter doing that, Mark.
Well, the filter's gonna bluify some of these things. It's gonna make all the stars look like a slightly more blue. If we look at things in white light, okay, then that's interesting. The white light image of the comet earlier, right here, you can see that the stars don't have that cast there, but you can still see the greenish blue because that green light from that filter is allowed in. Okay, but by the way, notice these 3 stars and the comet right there. And now let's go back to that previous photo we were just looking at. Okay, watch the comet and those 3 stars right there. Watch this. Okay, look, it's almost on top of those now. And now let's go to this next photo, and you'll see that the comet is now literally almost touching those 3 stars. Now, I said this the other night, and I'll say it now. If we have a spectroscope, like we're talking about, the spectrometer, we take a spectrum, say, of this star right here. Okay? We get a spectrum of this star. And then if the comet passes in front of that star, then the comet's going to pollute the spectrum of this star. Because the comet's atoms in this coma, in this extended envelope of stuff, are going to extract a little bit of energy from the light coming from that star. And so this star, this star's spectrum that we took earlier could literally be subtracted from the spectrum of this guy, and we'll actually see what was left behind, what elements were actually in that cometary halo right there. Now, these are glowing things, okay? So we're actually going to see some emission lines in here in this comet. There's going to be some lines because we're looking at energy being given off by the electrons going back into the carbon atoms. So we're going to see these green lines, cometary lines. But it's pretty interesting. I'm really pleased with how this telescope's performing, to be honest. It's looking pretty good. I think I'm going to try another exposure. We're going to go and do an exposure now. Dare I say, Daryl? I think I'll do a 2-minute exposure. Try it out. Okay.
So all the kind of red-looking stars at the top of the screen, they're just field stars or nothing?
Let me go see again. Let me see what you're talking about.
Like, see the larger kind of reddy kind of looking ones?
Right.
No, not even that one. Go back. Oh, no, go back.
Okay.
Yeah, like up between the date and the time, straight up from your mouse.
That's the same two he looked at.
Yeah.
Oh, is it? And then the one in the corner, on the right-hand corner?
Yeah.
So they're just field stars?
Yeah, they're all just field stars.
Okay, so they're not anything of import.
No.
Okay, I hope that helps you, Flames. They're just field stars, just the filter we're using makes them look a little redder, I guess.
Well, it does, but they are red stars. I mean, they are.
Oh, okay.
Yeah, but we're actually here's the thing. This filter allows light from hydrogen alpha, which is really red, like the Orion Nebula's red parts. That light comes in, so anything close to that is going to be shown brighter and shown to be more intense. So we actually see stars that have, more of these hydrogen Balmer lines in them, as they're called, when we're looking at stars with that filter. They will show up.
Okay, but it's the filter that's bringing that out, making them appear red. Like in the other frames when you were showing with the no filter, they just looked white. Or did I not see them? Did I miss something?
No, let's just go take a look again, all right? Because here it is. Okay.
Yeah, see, I don't see anything red standing out. You said they are red stars.
Yeah, look though. I mean,
you don't see them as red here. So it's the filter bringing the.
No, look here. No, they're orangey. These are orange stars. They're probably maybe K-type stars. Okay. All right. But they're made to look more red by the filter. Absolutely. But these are. I mean, compare this star. Okay. Compare this star with that star. They are not the same color.
Maybe it's a tinge of orange, but I mean only when you pointed it out and I actually physically moved closer to the screen.
Right, but Amanda...
leaning back at all, they all look kind of white to me.
Yeah. And what's the technique we've used to actually show? Remember this? We haven't done it for a long time, but what's the technique we've done to show what color stars actually are?
You turn off the drive.
I thought it was the spectrogram.
Well, that's one way. That's correct. But both of you are right. But what's the other way that we did very simply, Amanda? Remember we used to do this?
Defocus?
Yes.
Oh, yes. Oh, yes. It all came flooding back when Daryl said it. I remember that word from years ago.
Yeah.
Defocus, yes.
Yeah, we would actually defocus the star guys and.
Wait a second. I thought you defocused when you were using the spectrogram.
No, that's actually depends on very sharp focus. Because you're actually spreading the light of the star out, and the lines will be blurry in the spectrum. It
makes it look like a ring, like a hollow ring.
Well, that's the defocus.
Doesn't it like two hollow rings kind of?
That's the defocus.
Overlapping side by side.
Not side by side, but just like a donut. Yeah, that when you defocus, it makes a donut, and the reason it makes a donut is because of the type of telescope this is. This is a Schmidt-Cassegrain. So, what's that mean? It means that it has the barrel of the scope allows light in. All right, it goes down to the primary mirror and bounces back up to a secondary mirror that's right in the middle of the main opening. All right, and yes, it does steal some light, but the barrel's made that much bigger, so you have a certain amount of aperture that you get from that, a certain amount of clear aperture it's called. All right, but that secondary mirror is a round mirror that's up near in the center of the telescope's barrel at the end where the light comes in originally, and then that light gets reflected down through a hole in the primary mirror and goes out to cameras or your eye or whatever. In our case, it goes out to it'll go out to a camera, it goes out to a spectrometer, it goes out to a filter wheel. But that secondary mirror, when you defocus, shows up as a dark ring, a dark shadow, basically, in the middle of your defocused star image.
Called secondary obstruction.
Yes. Yep, the secondary obstruction, and just as Daryl says, hey, look, man, we're astronomers. We know our stuff.
It just makes the unfocused telescope, the image of the unfocused light makes it look like a donut, and the secondary obstruction is the hole in the middle of the donut.
That's right. That's right. And some telescopes have fairly big secondary obstructions. Mine is a fairly big one. But that's because the telescope's nature. This actually came out pretty good, and I'm noticing right there. I think do you see what I see, Daryl? Do you see the, I'm actually seeing two objects right here. Look at that.
Maybe.
Maybe.
Eyes crossed. No, I think you're right, and I looked that up a little while ago, and I think they did say it looked like there were two major fragments at the moment.
Okay. That's pretty interesting. Wow. Yeah, so, and sometimes, people just say, well, we just take a longer exposure. Well, maybe sometimes a longer exposure is not the best. So I'm going to go from 3200. I'm actually going to drop it again down 2 more stops to 2000. Now we're going to do it again and see. This will be fainter now, and this will be a darker background. But let's see if what's in the middle can be even more pronounced, because it's going to stand out as the brighter of the two objects, because this is fairly bright and then the objects in the middle are fairly bright. And we're going to see if we can actually start to separate them a little bit. We're having fun with Comet Atlas Y4 tonight, guys, and Y4 is on a strange orbit. We'll never probably go through the tail of this comet to make a meteor shower like we do with some comets. That's where meteor showers come from. It's the dust left over from the tails of comets that we then go through as the Earth passes through them. And I think you all recall the story that originated with a story Daryl brought up to my attention. It was Camille Flammarion who said that if we went through the tail of Halley's Comet in 1910, most likely we were all gonna die because of the cyanogen that was being given off by the comet, the green, that is to say. He was famously wrong, but he lived to regret that, I'm sure. Okay.
Is it question time?
Yep.
Okay. Next question. Ooh. Next question. Okay, and you guys can go first because all three of us were addressed.
Okay.
You guys don't usually ask my opinion because I don't know. I'll bring the questions to the people that do know, but I only have opinions and theories. So I don't have any facts. Okay, now this is an interesting one. On the subject of life, Daniel wants to know, what do Mark, Daryl, and Amanda think about life being a field tucked away in one of those Dimension M theories? Theory tells us are wrapped tightly around every Planck point?
Planck point, yeah.
What do I say? I say humbug. I mean, I'm sorry. I like to call it, that's the modern equivalent of how many angels can dance on the head of a pin. I won't touch that question with a 10-foot pole. Feel free, though, Mark.
Well, yeah, there's actually very little to say about it for me because I don't have a lot of opinions about that particular subject because now you're talking about the nature of life, right? Well, we don't even really have a definition for life other than it's self-directed and it makes decisions on its own, and it reproduces. It tries to survive if you threaten it, right? It makes it has survival instinct, but I don't. As you can see, I'm kind of like at a loss here. I'm trying to be, not cagey. I'm trying to be respectful of other theories.
Well, I'm sorry if I sounded disrespectful.
No. I certainly wasn't. No, not at all, Daryl. I wasn't trying to say that at all. Your opinion is.
I think that's navel gazing is what that is. It's silliness. That's what is that? Some kind of quantum mechanical, membrane BS. Who knows?
Well,
I have no idea.
The only thing
you can't see it, you can't touch it, you'll never be able to.
Well, we also weren't ever going to be expected to see gravity waves until we did. So I don't necessarily think that it's wrong. I just think that
Daniel's just looking for opinions.
I don't know. And
no one's opinion's ever going to be wrong.
No, I know. And my feeling is that, at our current point in our science, we don't have any definitive answers about the nature of life itself. We don't know what makes something alive. We know we can put a definition to it and say, well, it's self-directed, it reproduces, it does this, does that. However, what we can't say is, but is it really something that is alive? And what does alive mean? What does it mean to be a living thing? Does algae have a personality? We'll say dogs have personalities.
to another algae, maybe.
Right. Dogs have personalities, but what about a bacterium? Does a bacterium wonder about its future? Does a bacterium plan? Does a virus think about where it's going to go next? Does a virus think about its mortality? We don't, these are things that we assign to humans because we view ourselves as the most advanced species. But as a dog is running out into the road, does it think about that car, or is it only single-mindedly fixated on the squirrel running across the road? Just because of the nature of the way a dog thinks, it's probably fixated single-mindedly, which is why humans go, no, Scruffy, don't run in front of those cars. Okay? But, my feeling on that is that it doesn't mean that the dog doesn't wonder about things that we don't understand yet. Maybe they do, but they certainly, if they do, they think about it at a different level. Dolphins are very intelligent. Have you ever looked inside or looked in a dolphin's eye? You can't really look in both eyes. You can only look in one at a time. But you wonder what's going on inside that head. How about an octopus? I think the octopus is the smartest creature in the ocean. And we did a story, a show on KGRA radio, on SkyTour Radio. We talked about the octopus as potentially being the most intelligent animal in the ocean. It knows how to reason. It can puzzle things out. And most importantly, it can watch another octopus try to figure out the answers to a maze and figure out when it finally gets that answer, it can reproduce it right away. And they actually did that test where they had one octopus going into a tank and it had to go through several tubes to find its way out. Most of them were dead ends. There was one that led out. And when the octopus found its way out, then they let the other octopus into that tank. And it went straight into the exit that the other octopus was in and went right out. It didn't spend the 20 minutes trying to figure out all the answers. It went out the right answer right away. So obviously, it can observe and learn. See, so clearly, the life on Earth has got more capability than we're giving it credit for. And we're only kind of just learning this, by the way, guys. This is something that we're just learning. Every life form on the planet, even ants. Okay, next time you go to step on an ant, think about the fact that at some level, although it won't be missed by a family or others of its kind, because that's not the way their system works, that life has purpose and directed purpose. It has an idea of what it's doing, but we just don't know how to think about that at this level, because to us an anthill is just a little thing. We dig those up with an excavator like nothing. Okay, but the technology and the order that, for instance, an anthill demonstrates, or a beehive, is phenomenal.
Sorry, I read the cutest thing about an ant today, and you talking about ants made me remember it. Can I just read it? It's really, really short. It's not even a story. It was just a little blurb someone put out.
Please do. I wonder if it's
true or not. I just thought it was so cute. I actually shared it on Facebook. I thought it was so sweet.
Go for it. I wonder if it's the one about formic acid, the one I know.
No, this is a cute little story.
Okay, go for it.
Okay, so this guy, I don't know if he tweeted it. I don't know where it came from, but okay, it says, I was outside eating a cookie and saw about 5 ants just roaming around on top of the steps. And I noticed there was only one ant that wasn't holding anything, like the other four were holding Dorito bits or something. And the ant seemed sad and wasn't even going the same pace as the other ants. So I put a cookie crumb next to him, and he picked it up and started running as fast as the other ants, and I think I made that ant's little day. Little ant. Isn't that cute? I don't know if that's true. I don't even know who would come up with that, but I mean, I don't know. I could envision the whole story. I thought that was sweet. I hope you guys enjoyed that.
I did.
My contribution to the show.
Well, that's cute.
I I think that's anthropomorphism.
I was just gonna say those words, Daryl.
I don't care. I love it. I do. I give everything.
What Daryl is saying.
Emotions and feelings and personality.
That's fine. That's fine. I mean, but anthropomorphism is kind of where I was going to, and it was like, when you look at situations like that, you try to figure how would you feel in that situation. Oh, look, they all have something and I don't. I feel sad. Well, those are human emotions, and we actually, and there's no harm in what you did. That's fine, okay. But let's take it to a serious side. If an alien species were to come here, we can't anthropomorphize this alien species. We don't know if it has the same moralities that we would, fears that we have, capacities for evil that we have. We don't know whether it's the same, different, worse, better. And we wouldn't know. And so, we have to consider that if an alien species comes here, then we can't try to assign human emotions to it. Like, hey, let's do something nice for it, and it's got to like us. No, it doesn't. It depends. It depends on its evolution. It depends on its planet. On that creature's planet, depends on what it grew up with, it evolved with. It might come from a society where, like it's a hive mind, where the individual is not very important and the collective is most important. Sort of like the Borg. Yes, I know. But that's the concept of the Borg grew out of beehives, actually. So.
You know what I say?
Malarkey? What?
I say ack. I assume you get the record.
Mars Attacks.
I tried to show Amanda a clip from Mars Attacks a few days ago.
Oh, it's a great show. I like when they sing that song and their heads explode in the bubble. Ack.
Sorry, I dropped my mouse on the floor and I couldn't unmute. I seriously, when you guys were talking about Borgs, I seriously thought you guys were just talking about Star Trek.
Well, I was just talking about Star Trek with the Borg.
Oh, okay. Because when Daryl said scene from Mars Attacks, I was like, oh, maybe that's the noise that the alien guys make from that movie.
It was. He did go to...
Well, no wonder I'm sitting here confused. What are you guys doing?
Well, we actually... We talked about
here.
More than one science fiction movie. Yes, we talked about Mars Attacks.
And
yeah.
Since I haven't seen any of them, I'm trying to follow what you guys are saying.
Yeah.
Then I got confused.
The Borg, I mean, they were probably one of the best bad guys the Star Trek writers ever came up with.
Yeah.
And Borg, excuse me?
Was Worf a Borg?
No, he was a Klingon.
Amanda.
The Borg are the half robot looking ones. They're
you
sort
will
of
be
hive
assimilated.
mind androids. And Borg, of course, is just a short form of cyborg.
Yeah. You were not Morg. You were not I-Morg. Yeah. So here's the comet again. Earlier, you can see the comet here, the nucleus that's extended, and these three stars. Okay, and now it's a lower exposure, lower sensitivity, but you can see now that it's now inside these three stars. That is not really where it is. Obviously, these stars are hundreds or thousands of light years beyond this comet right here. But still, it's pretty interesting anyway that you can actually watch the movement as the course of the night goes on. You can see how it goes from here, okay, to there, to there, and to there. So you can actually see it moving. Oh, it's very, very cool. And that movement is something that, really shows you that the universe is in motion. Nothing's sitting still. Stars are whipping around our galaxy at really phenomenal rates of speed. Okay? But we can't see it because the galaxy is so big that even at these phenomenal speeds, it takes tens of thousands of years for most of that motion to be noticed. Only in the case of small pockets of locations like here where we are, there's a few stars in our neighborhood that are moving noticeably in the sky. Barnard's star being one of them. It moves several arc minutes a year, and you can actually see that motion over a period of months. A whole star moving at high speed through the cosmos. But you'd never know it. And then, so we'll see stars moving like that. Comets, of course, are these visitors on these really wonderful elliptical tracks around the sun. And they will find their way as well into like our understanding as objects that are seen to move, like they're doing here. Like here, you see it moving across the sky. In just a little while, it's now blocking these stars. And the coma of the comet, this area here, you can actually see it when we move it around like this. It's pretty clear what it's doing. It's pretty clear how it's actually pretty wide now. And that wide area here, that's part of the dust tail as well as the ion tail here. And I think that we're looking at the dust tail down here, actually, Daryl. And this might be the ion tail back right here. And
could be.
Yeah, but I think that we're also seeing it. It's so diffuse because it's broken up into so many little segments now. These three stars are not, again, these are stars way farther away. They're not the comet nuclei that we're talking about. Okay. Yeah. Thanks, Farva. Thank you. The movie Paul was very funny. I don't dispute it. Farva in chat here says, if you want full-on truth, watch the movie Paul. Paul is hilarious. Have you seen it, Daryl? Daryl's on mute.
Sorry, no, I haven't.
Okay. How about you, Amanda?
No.
Oh, Paul is a really cute movie. You know, it's about an alien that comes to Earth. That's as much as I can say.
It sounds vaguely familiar. Like, I'm sure saw the trailers for it. It's like quite old now, isn't it?
Well, I mean, not quite old.
It wasn't. I mean, I know it was like live action and I guess CGI for Paul, I would assume.
Yeah.
But it wasn't like. It wasn't Pixar, was it? It wasn't like somehow related to them. What company did it come out with?
I'm not sure. Maybe Digital Domain did the effects. I'm not sure. Mm-hmm. But it was well done. It was really, really funny. And then Lori says her favorite movie is Contact. Contact was one of these movies that it just ripped me apart because at the end she just
Spoilers! Spoiler alert!
Well, I guess that's true. I guess I shouldn't say.
No, just warning people. Just warning people. Yeah. I haven't seen the movie.
Oh, okay.
Should I take my headset off for a second?
No, at the end it doesn't work out the way you think it will, and it really makes me mad. She did. She took her headset off, didn't you?
No, I'm here.
Oh, okay, good.
Go ahead. I mean, I haven't seen it yet. It wasn't that. It was in like the 90s or something.
Yeah.
I haven't seen it. 30 years later, go ahead. You can spoil it. But I'm just saying, if anyone...
No. When was Contact?
Is taking suggestions from chat on good movies to watch. I don't want them walking in knowing the end, you know?
Yeah.
Contact, for me, I was disappointed in the book. I was disappointed in the movie. Carl Sagan wrote it. I think he tried to hedge his bets or tried not to commit. And the whole thing came across as pretty wishy-washy to me.
Well, how about the movie? And while we're here, let's talk about movies, guys. All of you in the chat, tell us your.
I may as well take off my headset.
No, I'm not going to give away.
I'd be stunned if you guys name a movie that I've seen.
You'll be stunned if we have?
Yeah.
Wow.
If you of all the movies you're about to mention, I would be stunned if I've seen any of them.
Star Wars.
Oh wow.
Well, there you go. Okay, so
you know what? I haven't seen the last three.
Okay.
Yeah,
I saw the original three, and I think I saw the three that were supposed to be the prequel.
Yeah.
And I vaguely remember literal part 3.
Okay. Thank you, Farva. 2011 was Paul.
No, I was talking about Contact. I thought that was in the 90s.
Okay.
But anyway, yeah, and I haven't seen part 7, 8, or 9 yet, and I haven't seen any of the spin-offs.
Okay.
So.
Oh, and Daniel Whitaker, Blade Runner, yeah. Definitely one of my favorite movies, okay? And you know what's funny is Rutger Hauer, the speech at the end when he died, the Tears in the Rain speech.
Yep.
Rutger Hauer actually, the script read differently, and Rutger Hauer changed it on the fly, and that change is what became the speech that epitomized the Blade Runner movie. And I work with the guy that actually did the special effects for Blade Runner. Okay, Doug Trumbull. Doug and I are very good friends. We work together on many movies. We're doing one on Nikola Tesla right now. And Doug did the special effects on that movie. And, you know, if you look at the blimp going over with the Japanese, influences, he's in basically... The entire movie basically takes place in Chinatown in some city somewhere, and only the wealthy people can live off the ground. So everybody else lives on the ground, including Harrison Ford. And so I thought that was just an amazing movie for the vision it showed. So yes, Daniel, definitely good. But hey, if anybody else has a favorite movie out there, go ahead and mention it. We're just taking some longer exposures here of the Comet to do some comparisons. I'm actually going to put all of them together at the end of the week or so, and I'm going to then take these images and show you the motion of the comet through the course of its time in our sky. 2001: A Space Odyssey. That's another one. Doug worked on. That was his first movie. Do androids dream of electric sheep? Right. Holy cow. Yes, that's right. My God, it's full of stars. I remember that. Yep.
Do androids dream of electric sheep? Philip K. Dick, if I remember correctly, and that was the genesis of the movie Blade Runner.
Yep.
I think.
I think you're right. Yeah, it was
Mark,
really
Amanda, will you folks excuse me, please? I'm running out of steam rapidly here.
All right, man. No worries. Daryl, thank you so much for coming by. I'm sure you could hear a round of applause from all the people in the chat who are here to listen. So I'm happy you came, man. Thank you for coming.
Okay, well, thank you for having me. And
Absolutely.
Amanda, you take care, and we'll be talking soon.
Yes.
Continue on, please, and have a good night. Good night, everybody.
Good night, Daryl.
Good night, Daryl. Thank you.
Good night.
Well, that was very nice. I'm glad that Daryl was able to join us.
Yes, definitely.
Yep. And now what everybody's left with is the
Daniel
original...
says Oblivion. Have you seen that?
Oblivion, huh? No. And Gene Schnitker says, Mark knows he's a massive Star Trek fan. Yes, I do know you're a massive Star Trek fan, Commodore. He is actually... you should see Gene Schnitker here. I saw him in Wyoming. He came to our talk I did at Devil's Tower at the UFO Rendezvous, Devil's Tower UFO Rendezvous. And it was really, really amazing, to see him there. He actually came with a few of his friends. There and Gene, I think you had your Star Trek uniform on, or at least a pin. I believe you had. I can't remember exactly, but you definitely stood out. You definitely stood out, and you wear it well. I gotta say that you wear it well. You would definitely pass for Starfleet. So it's cool. Yeah. So I think when you saw my talk, I think I did the toilet paper history of the Earth actually. Because I think
Not
I was...
the one I saw.
Huh?
Are you talking to me or Gene?
No, Gene.
Oh.
Yeah. No, you didn't see the toilet paper history of the Earth, I don't think.
I know, but I no. I thought you were talking to me, and you said when you saw my presentation, and I was like, well, I did see one of your presentations, but not the toilet paper roll one.
Yes, sorry, I
saw it on stream. I saw it. Yeah. I saw when Bill dropped it, but
he dropped 1 billion years.
But
no, I was just
talking.
talking.
I saw live didn't have toilet paper.
Yeah, I was talking to Gene because I saw him in Devil's Tower in Wyoming, and that was just a really, really great little meeting out there. Great little conference. Really, just beautiful out there. And the skies, of course, were so stunning they took your breath away. And part of that was because it was about 15 degrees in September. Wyoming's cold, man. So no observatory there. I would hate to do maintenance in the cold. Yeah, I am taking another shot here.
I really can't think of any space movies I've watched.
Really?
Yeah.
Well, you know what? I'll tell you a movie that was early, and I'm gonna just give hints. And
I can tell you an alien movie I saw. Speaking of old movies,
well,
The Day the Earth Stood Still.
Oh, that was a very good one. Actually, there was a remake too made of that. I watched the old one
recently. Was it Keanu Reeves?
Yeah.
Yeah. I didn't see that one. I saw the old black and white one from the 50s.
Yes.
Or whatever.
Klaatu, Nick Baratu.
I've actually seen that movie a few times. I like that movie. I thought it was really interesting.
It really was. You know, the world with the U.S. of course being the focus, because that's all we thought the world was in the early days, was the U.S. as the focus. And the world on the precipice of entering the galactic realm of the galactic peoples out there. But we weren't ready, you know?
And it reminds me of, like, a lot of Twilight Zone episodes. You know, like, obviously everyone's thinking to serve man, but there was another one where a woman is, the whole time it's one woman in her house, and she's under attack by these creatures that she believes invaded her home. And then the twist at the end was the invaders were actually us.
Yeah, and right.
It was like, and we landed on whatever planet, and that was the reaction the person was having to us having landed. Yep. They were freaking out because whatever, you know. So.
Yeah, the Twilight Zone. I like those psychological twists that they used to do. You know.
And that reminds me of, like, The Day the Earth Stood Still, when he goes to hand him something and they all pull out their guns, and he's like, I forget what it was, something like, this could have ended world hunger or something like this, or would have brought peace to your planet, or something wonderful for all of humanity. And he's like, but if this is how you're going to treat me, a visitor to your planet offering a gift, you know, screw you. And it's kind of like, you know, maybe we should have thought this through a little before we just reacted. And
James Dugan, Forbidden Planet. Okay, how about that one? Okay.
I never saw that, but that used to be Richard C. Hoagland's intro song.
Yeah.
The music from that movie.
Yeah, because Forbidden Planet was excellent. There was a race on this planet known as the Krell, and they managed to bottle up all of their hatred, all of their negative feelings. They figured out a technological way to take it out of their minds and stick it in a machine. And then because of that, something really bad happens when visitors from Earth come to that planet. And you have to watch it to see. That was really an amazing movie. Yep, just amazing. So yeah, I mean that's crazy.
So Eugene was saying the actress was Agnes Moorehead, who played
Agnes Moorehead,
Samantha Stevens' mother in Bewitched.
Yep.
Is it Andorra? I believe her name was.
Andorra, yeah.
Very cool. Yeah, no, I knew it was a famous actress, and I remember seeing the episode knowing it was her, and I couldn't even see it. I guess I'm so used to the wig and the elaborate makeup and jewelry and costume from the show, right?
Right. Really, Durwood.
Yeah. I actually did. I just thought of this. I saw last summer. I saw a Douglas Trumbull movie, and I can't remember the name of it. And I was watching with a friend, and we were kind of talking through it. So I don't remember the exact details, but
was it robots on a ship in space?
No.
All right,
they were in a science lab, I believe, and I think they were doing experiments on the brain.
Oh, then that was Brainstorm.
That sounds familiar. It could have been Brainstorm.
Yeah, that's the movie that Natalie Wood died on when she was working on Doug's movie. She died there.
Wow. Really?
Yeah.
I did not know that.
Yeah, that's the reason Doug quit the movies. He moved to Massachusetts, which is the state right above mine. And that he did that because he couldn't stand watching the Hollywood, the Hollywood monkeys out there trying to turn this into something it wasn't, He got sick of it, and he just left. And he went to raise donkeys with his wife at the time in the woods of Massachusetts. But 30 years later, the movie business came calling again, and he felt like he wanted to get back into it. And that's when I met him, and we ended up making stuff together, doing stuff together, and we communicated at a very good level. He's a really good guy. Oh, thank you for.
I'm glad it worked out that way.
Yeah. And so Forbidden Planet was really good. And right, the creatures are the id. That's right, which is their personalities, all trapped in the machine.
Because Eugene actually said that Forbidden Planet was actually The Tempest, set in space.
Oh.
And I do like Shakespeare, so I might actually give that one a chance. I know I'm biased. I'm sorry, but I don't know.
Fair enough. That's fair enough. Yeah. By the way, are there any more questions? I really...
There are.
Okay, well...
I actually... I mean, I kind of want to go back, but I don't want to take up, so much more time on this question because I think it was kind of the question that started it all off. About life being tucked in a field somewhere in another dimension. I don't even understand what that means. I'm not sure what he's referring to.
Well,
I've heard of other dimensions and stuff. Is that what he means? Life being in another dimension? I don't understand what he means. Does that mean, afterlife? Do we go to another dimension when we die? I don't know what theory this is.
It can be any of that, I mean, we don't know. We don't know. I do, again, I have a unique perspective from what I've gone through. And I do think that there is another weird... Remember, I'm a science guy, okay? So this was very hard for me to not only accept, but to go through. And for those that don't know, I mean, it was 5 years ago. I was a quadriplegic and I was blind. And before that, I was perfectly fine, and I had to have surgery, but the surgery went kind of sideways. Doctors did their best to save my life, but I ended up, in that condition. And I had to kind of bring myself out of it. But during that time, I experienced some things that were, I don't want to say ethereal or whatever, because that sort of starts bordering on almost religion, and this wasn't. This was a very different set of circumstances, very different. And I'm trying to figure it out scientifically. Suffice it to say that lying in the hospital, profoundly blind and as a quadriplegic, I knew I was going to be just fine. And it's because during the surgery, when all this happened, I was wide awake for it, in that I was being coached on how to manage it. And it was the weirdest thing in the world. Again, I'm a science guy. None of it makes sense to me either. But I can tell you that it is one of those mysteries. So is life tucked away in a dimension? I don't know. Because, I mean, Daryl has his opinions, but I think that there's something else going on that I cannot explain. And I don't know how to explain what happened to me. So, I mean, it just, I know this is sounding crazy, guys, sorry. But I'll leave it at that. Anyway, I thought it was pretty interesting.
Well, see, sometimes I think maybe I just play it safe because I don't know. I feel very skeptical on a lot of things.
Yeah.
But yet I think anything is possible. Like, because I don't know, who am I to rule something out totally? You know what I mean?
Sure.
Whether I believe in it or not, that's another subject, but I don't know.
Yeah.
I mean, like, people believe in heaven, so is that so far off saying, like, people are just on another wavelength? Is that so far off to say it's another dimension? Is it so far off to say, like, maybe, our brain just can't process certain things? We just haven't, explained them or seen them yet? Or, I mean, there are too many what ifs that you play out in any situation, so do I believe it? I don't know.
Yeah.
I'd like to believe it. I think everyone kind of wants to believe there's life after life, but then I don't know.
Well,
are we energy? Do we reincarnate? Do we go to another planet? Do we come back here? I mean, like, there's so many scenarios that,
I realize.
It's almost like, I
No,
don't know.
no. But see, you're going down the path that is what I think sparks the beginning of all philosophies, right? Here we are looking at this beautiful comet out in space. It's just less than an astronomical unit from us right now. It's tooling along, and it's gonna go around the sun. And this has been here around our sun, going around our sun for 4.6 billion years, perhaps. If it's a periodic comet, there's some indications that maybe it's hyperbolic. It's a potentially a one-time visitor, but I think it's actually. It's probably a comet that could be periodic, but we're watching potentially the death of a comet that's certainly, the object has been around since the beginning of time for the solar system. It was created probably 4.6 billion years ago, and we're witnessing it dying. We're witnessing the end of its existence. So I think that's pretty interesting. Now, a comet isn't such a big deal, but I'm an exoplanet astronomer, right? So I think about planets around other stars and study those. And we found planets, and Amanda, you know this because we've talked about it on SkyTour Radio on kgradio.com and on our show. And there's planets that are so close to their star that the star is ripping their atmospheres off, and the planets are evaporating. They're so close. Now, you might say, well, wow, how is it that we managed to see it at this point in history? What a lucky find. Well, it's either that, it could be a lucky find, but it could also be that maybe the planets that are in star systems that are unstable will spiral toward their star over time. So there's a certain percentage with fairly good likelihood that maybe that's happening elsewhere. Now, it depends on the star. If the star is shooting off lots of material that go out into the outer star system and collides with a planet that's in orbit, well, that impact on the planet could affect its orbit, maybe slowing it down. And if it slows down just a little bit, that means its orbit is going to get smaller. It's going to end up getting closer to the star, maybe going more elliptical. And then every time it goes around the star, that just, it goes up in magnitude, more and more and more of that stuff collides with the planet, and it slows down more and more and more, and the orbit gets smaller and smaller and smaller, and eventually the planet can spiral in to the star. That's what that spiraling in thing is all about. And what we say that it's spiraling in, well, then perhaps that's something that we have seen because it happens a lot in the universe. So, I mean, it's not happening here. This particular star system is stable at the moment, but in about 5 billion years, the sun is no longer going to be stable, and it's going to swell into a red giant. And that red giant will most certainly swallow the orbit of Mercury, the orbit of Venus, and perhaps the orbit of Earth. But if it doesn't swallow the orbit of Earth, let's say it goes out to Venus, well, then that red giant is going to start throwing off what are called mass ejections. We know those now as coronal mass ejections from the sun. Okay, this is high energy protons, electrons, plasma. Okay, and material, hot physical material that's going to come off the sun, and it's going to collide with the Earth. It's moving through its orbit at the time. Now, Earth will have long since died. There won't be anything here for life, but that's going to impact the Earth, and it's going to slow the Earth down imperceptibly. Well, the Earth maintains its orbit around the sun because of its orbital speed. If its orbital speed is reduced, well, then that orbit's going to get smaller. It's going to end up orbiting closer. And so over time, it will spiral in to the sun as well. And that's the fate of planets that are orbiting red giants, potentially. So you see, but there's a lot of things that are going on out there, but and maybe we're seeing the death of a comet because lots of comets die, and so this really isn't anything special. We saw Shoemaker-Levy collide with Jupiter. It made a string, like a string of pearls, that collided with the atmosphere of Jupiter. Each one of them, the equivalent of many, many megatons of explosions, So I think it was just an amazing sight. I watched it with my backyard telescope back when I was living in another location. And it was just stunning. It was beautiful. But it was also quite frightening. I thought, what would happen if that hit here? It might take us out, and maybe it could have. So it's really pretty... and you think about this stuff, and you end up wondering, how lucky the human race is. Now, on Earth, we've had 5 major extinction events. Okay? 5 major extinction events. And those extinction events were the result of a variety of things, not all the same thing. One of them, which wiped out almost 98% of life on the Earth, was probably due to a massive set of volcanic eruptions in what's now Siberia. Okay? That was the Permian era. Another one was due to a change in what's called biodiversity. When the sun throws off ultraviolet rays, perhaps this sparks all kinds of mutations in the genes of creatures. Some of these mutations are favorable for the existence and some aren't. Maybe the sun was at a more quiescent, less energetic phase, and less mutation occurred at this point in history for millions of years. And so species didn't change much. The net result would look like species declined, So we had that. We had an asteroid strike off of the Yucatan 65 million years ago. We call that the Cretaceous-Paleogene boundary event. Every one of the events, from the Cambrian to Devonian to Ordovician to Silurian, all of those are punctuated by known changes, many of which are extinction events caused by something. Okay, well, when the Cretaceous-Paleogene boundary event occurred, that is the collision that killed the dinosaurs, that was a process that took thousands of years to actually come to fruition, actually happen. They didn't all just die. Their food source was killed when the atmospheric clouds of dust that were thrown way up into the stratosphere circled the globe from this impact, and it turned day into night for months and months and months, maybe a year, maybe more. And plants died, and the plant eaters that ate the plants didn't have any food, and so they died off. And then the meat eaters that ate the plant eaters couldn't survive, and then they died off, and it was a domino effect. Bam, bam, bam. And creatures died one after the other. Species died. And this is an extinction event. So extinction events aren't catastrophic that all happen all at once. Now, they could, all right? Like if a Mars-sized body collided with Earth, yep, the entire Earth is going to be molten again. And, your final moments will be hanging onto walls as they're shaking apart around you and wondering what the heck happened. And then, of course, the atmosphere would be incandescent. It would get hotter than anything. All human life would be extinguished. And then the entire planet would be molten again, and life would probably start again. And given the age of the sun, if this happened tomorrow, we might have enough time for life to arise on the planet again. It took 4.6 billion years before. Maybe it'll take a little longer this time. Who knows? Maybe it'll be shorter. We don't know. But because it took 4.6 billion years doesn't mean that it would always take that long. Because the set of what we are now, the set of humanity right now that we have on the planet, is the result of 5 extinction events that occurred here on this planet. Well, what would happen if we hadn't had any extinction events? 252 million years ago, the Permian period, there was this volcanic eruptions process that occurred in what are called the Siberian traps, and this ended up catastrophically catapulting many billions of tons of carbon dioxide into the atmosphere within just a few days to some weeks. And that process caused the oceans to warm up, and oxygen left the waters. Most life died. It was a very catastrophic time, all because of catastrophic eruptions. So the thing is, what if that didn't happen? Well, during the Permian, the animals that would become mammals, which is what we are, the pre-mammals, were dominant. And the Siberian eruptions allowed the reptiles to arise as the dominant species because the mammals, the pre-mammals, couldn't handle it. And thus began the age of the dinosaurs. And that's when dinosaurs came about. Had there never been a Permian extinction, I wonder what life would look like on this planet. Another science fiction story for one of you out there. Start it up. So yeah, there's a lot of paths we could have gone on. A lot of paths. But we're on this path, and I don't know. I can't say for sure where we're going to end up. I just know that we are what we are because of all the things that happened to us previously. There, Amanda, I've said what I'm going to say.
Very deep ending there. Could be said the same about each person.
Well,
who came before makes who they are today.
Yeah, that's true. We're basically talking about evolution, which is mutation followed by adaptation.
We still do have some questions. I think this one might have been addressed by some other people in chat earlier, but I don't really know about this, so I think maybe it would be good to discuss.
Yeah, go ahead.
Jensen wants to know, are Centaur comets accepted as proven concept in astronomy, and is there any possible chance that Comet Atlas is one of these?
Centaur comet, huh? That's a good question. I don't know if Atlas is a Centaur comet. I don't think so.
What is a Centaur comet?
Well, a Centaur comet is a comet that's a small. It's a real small body. Okay, let me explain in a way that is actually reasonable. I'm trying to figure out. Now, first of all, it's not a Centaur comet. It's centaurs. Okay, there's small bodies in the solar system. Okay, that generally don't have very stable orbits. Okay, and so I guess to identify whether something's a centaur, you have to kind of know where it came from. And it was the first one that was found was way back in 1920, believe it or not. Okay, and in trying to figure out the objects that are centaurs is really kind of hard. There's now our centaurs objects that are more than a kilometer in diameter, and if there's an estimate that we can say that there's a number of objects in the solar system that are more than a kilometer in diameter, then maybe we're talking about a few tens of thousands. Okay, but they could also be up as high as 10 million. So the Centaur, it could be. I can say yes, it could be. And I think that the Centaur, and we actually talked about centaurs on SkyTour Radio. Actually, if you remember, I don't know if you remember, but we talked about bodies in the solar system, Kuiper belt objects, trans-Neptunian objects. Do you remember that? We talked about those.
The which?
Trans-Neptunian objects, the ones past Neptune. Yeah. We also talked about centaurs. And we also talked about the Sentry list, Sentry, Sentry list, not Centaur, which is Centaur. Okay. And the Sentry list was that list which put potentially dangerous near-Earth objects onto it, and they were actually determined to, one by one, to be non-threatening to the Earth, and were removed from the list. Atlas Y4 may have gone on that list and then been removed once they figured out its orbit. Many comets go on that list and get removed after their orbits are determined. Anything that we don't know that we find is going to be a potentially dangerous object until we figure out its orbital elements, as they're called. That's the parameters that tell us how its orbit's going to look.
And Chimera?
What
Chimera?
that? Chimera? Chimera?
So, yeah. Aren't there centaurs and Chimera? No.
You're saying chimera?
I think so.
Okay, I don't.
Are there other kinds of comets? No.
You might be right. I mean, yeah, it's possible. Okay, I don't know for sure. I'm not giving a good answer on that one. Okay, but I'm not familiar with the chimera. If there's, I haven't seen that. I mean, I'm familiar with scattered disk objects. Okay, those are the SDOs we talked about. I'm familiar with the centaurs. I'm familiar with all the minor planet family of stuff. I'm familiar with the trans-Neptunian objects. Okay, as far as centaurs, right now, those are, again, the small bodies that are out there. There's 450 of these that are known right now, and I don't believe Atlas is one of them. Atlas Y4 anyway. But I'm not sure what that chimera comment is, and that could just be me not knowing what they're referring to. So that could be a little bit of a problem on my end. So I may not know what that. I don't think I know what chimera is supposed to refer to.
I don't know. I thought for some reason it's reminding me of Greek mythology, but I know that's where centaurs come from. So.
Okay.
I don't know. Maybe it was a joke that I just didn't get. I don't know. But sorry, we couldn't be more helpful on that one.
Well, you can ask, and we can find out, right?
Yeah. Well, hey.
Yeah. No. If you want to explain more, please do.
Oh, wait. Hold on. You just posted something. Chimera are a system with rock, metal, and ice bodies all conglomerated. So is that like a kind of asteroid, maybe? No, metal.
Well, that's okay. I mean, metals are in asteroids. Okay, we have titanium in the moon. That's metals, basically. Of course, metals in chemistry aren't necessarily metals that you are familiar with. Mm-hmm. Metals are anything other than hydrogen and helium to an astronomer.
Yeah, I remember you talking about that before.
Yeah.
It's a weird concept.
Yeah.
Well, I mean, obviously, I don't know what that chimera is, but that doesn't help you at all, that description?
No, I mean, I know that from...
A small group all orbiting. I'm not sure orbiting what? The Earth? The solar system? If centaurs are trans-Neptunian objects, maybe he means orbiting.
Well, centaurs... I'm
just guessing here, I don't know.
No, but the centaurs aren't necessarily... basically, those are objects that are not trans-Neptunian.
Not trans-Neptunian.
No, they basically they'll be within like Neptune and Uranus's orbit, and then come toward the Earth. I mean, so that's possibly come to the Earth. I mean, maybe not necessarily come to the Earth, but their orbits are definitely unstable, and that's kind of important to emphasize, because that's the reason why they get here is because their instability.
It's a small group all orbiting the sun. A small group of a system of rock, metal, and ice. So I'm not sure.
Okay. Well, I think that I'm not familiar with the chimeras. I want to say it's a chimera. That's what I want to say. I'm not gonna try and answer a question where I don't understand.
Yeah, no, of course. We'll keep our ears out if we ever hear that term again or see it come up. I mean, maybe we can get back to you, but
yeah. No, when it comes to stellar evolution, I'm golden. You want to talk about that, I can handle it. But talking about some of the near-Earth asteroids and some of the asteroids, talking about particular objects in the Centaur list, I probably won't know all of them for sure. And then other asteroids, there's many families of asteroids, and I'm certainly have dealt with them, calculated orbits of some, but I don't remember those. They weren't, to me, they weren't memorable calculations, so I probably just let it pass out of my head and moved on to more cool things like why nebulae do what they do and what can we do about faster than light propulsion, But hey, that's me. I have my I'll basically do what I have to do, to learn about some of these things. But so sorry about that.
Okay, no problem.
It's not often that I haven't heard of something. But
no, Daniel says that he's going by memory. He'll look into it more, and maybe it'll come up again. I'd be interested to hear.
Okay.
Okay. Jensen asks, and I don't recall seeing any suggestions in chat. This might have already been addressed in chat, but we'll see if Mark has an opinion. Jensen wants to know if anyone had any recommendations on a beginner's astronomy book. He'd prefer one that focuses on astronomy in general, not just how to find things in the sky for beginners type book. Thoughts, Mark?
You know what? There's a million thoughts here. Okay. There's a number of really good books out there. If you want regular book, you want eBook. I mean, there's a number.
Give them a couple each.
Well, let me get the titles for him then, because I want to try and make sure that I get the titles right. Okay. So he wants something that's not
just how to find things.
Okay.
Not probably just not like a map book kind of thing, a map of the sky. Just
okay. Then
I think Jensen is still here. Jensen, if you're still here, if you want to be a little more specific on the kind of book you're looking for, like what specifically about astronomy, like
well, if he wants
where to start,
if he wants a PDF version, it's been out for a long time. This is basically it's called Astronomy: A Beginner's Guide to the Universe. It's in the 8th edition, and you can get it as a PDF. It's $15, and it is, it basically, it's just the book, okay, and it's a wonderful introduction to astronomy. It's almost 600 pages, so it's full, and we're talking, if you want to get the PDF version for $15, it's certainly worth it. And it's a book by Macmillan. They're actually very good. I actually taught an astronomy course using another book by John Gausted. I'm trying to remember the name of it. Of course, it was astronomy. And it taught you about the spectrum. It talked about a lot of things, and the students really enjoyed it. But it's a beginner's guide, and it's in its 8th edition. So it's Astronomy, A Beginner's Guide to the Universe. And I would say for $15, you can't go wrong on that one. It's a really good book. Yeah. And it's one where it's not about, it's about learning concepts in astronomy. It's not about finding stuff in the sky. Okay,
I think that's what he's after.
Yeah, that's the thing that book is especially good at.
And okay. Hold on, let me see if I can find it. Who's the author?
Chasen Macmillan. Let me get the name exactly right. Okay, it is
The Gray Zone?
No, Astronomy: A Beginner's Guide. What are you talking about? What's the Gray Zone?
Oh, the name of the book by Jason Macmillan.
Yeah, no, it's Chasen. No. Chaisson.
Oh.
Macmillan. Okay. Astronomy: A Beginner's Guide. It says A Beginner's Guide to the Universe. That's like I said, it's 8th edition.
I thought you said you couldn't remember the name of the book. That's why I'm trying to look it up.
Oh, I'm sorry. No. Eric Chasen did it, and Macmillan's the publisher.
Oh, okay. Yeah. Okay.
Yeah. I was just giving you the name and the publisher. Sorry, but
the 8th edition, I think.
Yep.
That's the most recent. Maybe.
Right. Eric Chasen.
No, it's 2016.
Yeah. It's recent. It's good.
Okay.
You should spend $15. You'll learn more astronomy than anyone else in the world. Can you imagine? Can you guys imagine if she bought the book and quietly studied it and didn't tell anybody? And then when they said, and then we talk about, in a red giant star, when the hydrogen is depleted, and then of course she just says, "Oh, you mean when the helium flash occurs, and then the second shell begins to burning just outside the core, and the star swells?" Well, yes, Amanda. How'd you know that? I just figured it out. She could play some.
Bored last night. Sleep.
She could play some really
quantum physics.
Yeah, right. Well, there's no quantum physics in this book, so you're okay. Yep. Yeah, Patrick Moore's Atlas of the Universe is kind of cool too. But it is outdated. But you know what? What's outdated is actually the information that Patrick understood at the time. Because things change in astronomy, things change very fast. That's why this one, the 8th edition I'm telling you about, the reason it's in the 8th edition is because it's been updated for all these latest things and the latest finds. So I really think that it might be a good like a very good book actually. So for that, so it's really good. I would use that's the kind of book, for instance, that I would use to teach an astronomy class.
It's the exact book you use to teach an astronomy class.
Well, it's a one semester class. It's a one semester book.
Yeah. Cool.
Yeah.
Okay, we didn't really talk about this per se, but kind of. And again, these are going back.
That's okay.
I think these questions came in like an hour ago.
All right.
I'm sorry, but thank you guys for your patience. Farver wanted to ask, if the Earth passes an arsenic gas cloud, what would be the effects on humans, and would nitrogen help relieve the stress of the lungs? Now, we were talking about, I can't remember the year, 1910, did you say? 1911?
Correct.
When that comet was passing, and that was the theory that there was going to be, it wasn't arsenic, it was...
Cyanide.
Cyanide? Yeah. And that we were all going to die, so I guess maybe they were thinking along that lines. What would happen?
Okay, well, let's just...
And I'll be right back.
Okay, let's just take it for what it's worth. If you consider that cyanogen, carbon and a nitrogen atom, CN, cyanogen is deadly to humans, but you need a certain concentration for that to be deadly to humans. And in the coma of a comet, such as this, right here, this green, everything you're seeing here is cyanogen. And this diameter is, in real terms, this diameter could be as big as like half the sun's diameter. The sun is 865,000 miles across. This could be 430,000 miles across here. And Atlas was showing us a very big coma, this bright stuff here. However, the most important thing to understand is that the density of the material is not very high. So when you look at a comet like this and you look at this green, you think, oh my gosh, that's all cyanogen. What if Earth collides with that? We'll all be bathed in cyanide. We'll all die. Well, if it was at a sufficient density, we would. But this is called a rarefied gas, a rarefied material out here, meaning there's not much of it for every cubic centimeter. Right? There's just a few atoms per cubic centimeter. It's not very dense. So it's only densest down at the nucleus core of this comet, right? And this particular location doesn't have a whole lot of stuff that is out there that can damage us because it's not dense enough. The Earth will sail right through it. Some of it might settle into the atmosphere. Particles might, burn up in the atmosphere as we go through the dust tail of this remains of this comet. But we won't find people dropping dead. They're not going to die because the cyanogen will never get to the ground, for one thing, and it will be mixed into the air. It's such low densities that you wouldn't even know it was there. It'd be maybe a few parts per million, if that, maybe way less. So we wouldn't actually have anything to worry about here. So we don't have to care basically about that. I'm going to drop this down again. I'm going to go really low. I don't know why. I'm doing a minute and a half at 1,000. I want to try and see if we see any details here. Okay, here we go. So we don't have to worry about that. And I'll check out the chat right now. Actually, I do actually want to spend a moment to just say hello to everyone that's here. There's a number of people that are here, of course. Terry Croft, I see you here. That's great. Farva's here, of course. Daniel Whitaker, Phil Wynn, I believe, right? That's how you pronounce that, I believe. James Dugan was here. Dave Schmidt was here. We have a number of people. We had Daisy and Zoe were here with Lane, their cousin, which is wonderful. Don't know if they're still here. Maybe they are. Maybe not. Just passing through. Tara was here. Eugene Schnitger was here. Lori's here. Good to see you. And we had a whole bunch of new faces here tonight. It was wonderful. Weird Guy was here. He's been here before. Not so weird. Nice guy. Flames was here. Flames of War. And it's amazing that we have such a crew of people that come out to this, 1235P Victory was here. And don't know if that he's still here either. But it's okay if you've moved on. Was here. So anyway, thank you for coming out and spending this evening here with SkyTour LiveStream with me. And Daisy and Zoe are still here. Fantastic. And then Puda is here. Hey there. Glad you're here. But you know what? We actually had a lot of people here. We've actually been going up in our numbers, and I've been very impressed with how many people are actually choosing to come up,
Yeah, I'm not sure if it's because of the comet or if it's, I know Bill was getting a lot of views on his streams the last few nights for the meteor shower.
Yeah.
Or if it's because there are so many people that, are stuck in home and might not have to get up early the next day and whatnot. But
yeah,
I really hope, for whatever reason, I really hope this sticks with people. I hope they have a really good time. I hope they feel comfortable in chat. I hope they learn things but are also entertained. I hope they're just overwhelmed by some of the images you get. And, I hope when all this is over, or just because there might not be a comet every night or a meteor shower every weekend, I hope people do, subscribe, hit the bell, and come back.
Yeah, me too,
It's worth it. It's a wonderful place to hang out. I mean, some of them go late. I know it's hard for some people, but they're always uploaded after the fact. Being here live is a little more fun maybe, but the information will still be here, the images, so
yeah.
So welcome to any newcomers, and please come back.
Like Justino Anelli, how you doing?
Yes, it's a name I didn't recognize, but welcome.
And Tara's still here because it's fun. I love it.
Love it.
Yeah.
Oh, that's why I keep coming back.
Yeah.
We have some more. Oh, by the way, I just noticed
and
when
thank
I came
you,
back
Philip.
from chat.
Thank you, Philip Wynn. I thought that's how it's pronounced. Thank you very much. Yeah, go ahead.
Yeah, I posted the link about the book, but you said there was a $15 PDF one. What one is that? Help me find the link and I'll post it for you.
Yeah, that was for that 8th edition I was telling you about.
Farva's saying it's like $107.
Not for the PDF version.
I sent the Amazon link. I don't know where the PDF link is. How do I find that?
Oh, okay. Let me go look for you and find that.
Well, that's quite the difference. Advertising something for 15 and,
Yeah.
Comes to 107, my God.
Yeah. No. It's the PDF version is just $15, and let me this is the one that is the definitive one. I think that's probably good. All right, let me I don't mean probably as in.
You just tell me. I can look it up, or unless you already have it.
I do already have it. I'm gonna drop the link for it right in here now. There's the link. And you'll remember it, Amanda, because it has Kitty as one of the first parts of the website.
Is that going to be too long? Press enter.
Oh. Ooh, maybe so. Okay, that link was kind of long, huh?
But it looks like by one character, yeah.
Yeah.
We're working on it, folks. Welcome to live radio.
You know what I'll do? I know what I can do. I know exactly what I can do. I know
there's a way to make a short link, but I don't know what it is.
No. I'm going to do this. Watch. I'm going to go down here. Let me just select it all. Hold on, folks. I'm trying to get this link out there. Put in, and it's too big by one letter, so what I'm going to do is remove there. That should do it. Okay, there's the link. Try it and see if it works. Go ahead, Amanda, see if it works.
No, because it's not a live link. But I saw what you did. It's the HTTP backslashes that's missing from the top of the.
Yeah, but you don't care. You can actually just copy what you see there.
I'm gonna try. That's what I'm doing right now.
Okay. And this
okay,
is...
seems to work. Yeah, $14.99 PDF version.
Yep.
Okay, that should work for you guys. Please let me know if it doesn't. I'm not sure what I'll be able to do about it, but I'll see what I can do. Let me see. Hold on, let me see now if I can copy this and make it live. Hold on a second.
All right.
Darn. Can I? Darn. No, because it's putting the HTTP back in.
Okay.
Okay, if you guys just copy and paste that into open tab, it should still bring you there. It did for me, so.
Yeah, it will. It's a browser.
Or can you go to kittypapdat.com and just Google it? Just search it.
I don't know. I just know that this is. I think the PDF version is probably the one that people would want, because then they could put it on various systems. They could read it wherever they are. They could secretly read it while they're having dinner, and make it look like they're doing something else important, but they could actually be just looking at this book. I didn't write this book. Eric Chasen did. So, yeah, but hey, not bad. Not bad. The e-version of my book's only $9.99. And I think that's a good deal. It's over 400 pages, 450 pages, the ebook, I think. Hey, Johnny Yu, welcome, man. I haven't seen you for a long time.
Welcome back. He was here earlier, but he lurks a lot.
Yeah. And Pickle Pea, hey, what's going on?
Sorry, I got distracted by looking for...
No, that's fine. That's fine.
Okay, let's see what's going on.
I'm taking other photo, guys. I'm just doing...
Terry said copying and pasting the link worked for him. Okay, so it should be good, guys. Should be good. And it came up $14.99 on my site. That's Canadian. It may change slightly depending on your country, but...
Yeah, going to America, it's $107. No, just kidding. Hey, Terry, how you doing, man?
Good night, Lori.
Well, Lori's going to bed. Lori's leaving us.
Oh, she might not be going to bed, but she's not staying here.
Oh, okay.
Let's see. We have... Okay, so you answered about Earth passing the arsenic gas and everything?
Yeah.
Okay. Now, Victory had asked me, this was way back when we were talking about would we have the right to terraform another planet, and about, animals having souls kind of thing.
Okay.
And he gave me a quote from the Quran that he wanted me to read you. I'm not sure. I don't think he's really asking anything. Maybe he wants your opinion on something.
Okay.
I'm not sure. I asked, but this was it. It said, there is not an animal that lives on Earth, nor a being that flies on wings, but forms part of communities like you. Nothing have we omitted from the book. They are all shall be gathered to the Lord in the end. So I'm not sure.
It sounds like he's just making a statement.
Well, that's what I was thinking too, but he asked me to bring it to your attention. And I said, like, I'm not really seeing a question here, so I'm not sure. But that's when we were discussing, do we anthropomorphize or whatever the word is?
Anthropomorphize, yeah.
Yeah.
Well, no.
Or is that what we're doing, or is there actually something that some of us are seeing there, that they do have, emotions and souls?
Like I was saying earlier, I think that perhaps there's more than meets the eye with other creatures. Like I said, the octopus, you watch an animal puzzle something out, okay? You watch an octopus figure out how to get out of a maze, and then you watch a second octopus go right through the maze and go out the first time properly. Now, that means they watched, observed, and learned. Now, that is just, I mean, that knocks me for a loop. They watched, and learned and repeated what they saw. That's, and at first, I thought many ways around it. And there's a reason I'm going down this path. If an octopus got out, it doesn't know it's found the exit until it gets out. So it's not like it can leave a trail saying, okay, this is the right path, follow this path. Here's a chemical marker so you can follow me down this tube. Okay? It doesn't know it's the right path until it actually finds, hey, I'm out. Now, in order to leave a marker for its buddy, it would have to go all the way back in and come all the way back out again. But that's not what happened. It got out and went to the rest of the main tank. The other octopus watched what it did, went in the same tube it went in, and found its way out the first time. So what I'm getting at is they have better powers of observation than people. So in some ways, it'd be great to be able to harness that power to remember complex pathing the way this octopus did and the way they learned. This is incredible stuff.
Definitely.
Yeah. So here's the comet again, guys. There's those 3 stars we saw earlier, right there. If you notice, if we go a little bit earlier, let's say to here. Okay, this is... Okay, you can see those 3 stars are inside. Okay, and then we take pictures again. Let me see here. We waited a few minutes, and you can see now that 3 are here. Okay, then I took some different settings, but you can actually see now that the comet actually is moving down this way. But you'll notice you would think that the tail should go this way, right? You should follow the path of its motion. You would think. So from here to here, it seems like the comet's just going out this way. Now you say, how can that be? If it's going this way, shouldn't the path be along that way? Well, the dust tail will be along that way. But this tail is the one that is a tail made through electrical interference, that should say, electrical interaction with particles from the surface of the comet. It's an ion tail. So we're watching stuff getting blown back away from the sun. Whatever direction the sun is, this is being pushed away from the sun. And that is what's called an ion tail. And these particles interacting magnetically and electrically with the solar wind that's hitting the comet end up forming this ion tail. And so the ion tail's always facing away from the sun. So as it goes around the sun, okay, all right, as it goes around the sun, the comet's tail will face away at all times. Now, what does that mean? It means, I'll show you. It means that, okay, if the sun was here, okay, let me just grab something here. It's not working. I'm trying to get my whiteboard here to work. Okay, it's not working yet. I was hoping I could get that to work for you tonight. It's not doing it. Just a minute, I'm trying to see here. Okay, maybe if I select. Let me try and just select. Nope. Hang on, folks. I'm just trying to catch a little. All right, no. Okay. I'll do it this other way then. Okay. So if this is the comet's tail going away from the sun, so if the sun is here, as the comet rounded the sun, the comet's tail would be facing away from the sun, be facing this way. On the other side of the sun, it'd be facing that way. And if the sun again was here, by the time the comet was here, the tail would be facing this way, and the comet might be going into its own tail. But that's the ion tail, not the dust tail. The dust tail is always a trail left behind it of dust like Pigpen, as I've always said in the Charlie Brown Peanuts comics, always leaving a trail of dust. That's what this would be like. So in this case, when you have an ion tail, the ion tail is, because it's a magnetic electrical tail created by the particles from the sun, it's always going to be pushing particles away from the sun. And no matter where the comet is, it's going to be pushing particles away from the sun. Okay, and on the way out, the particles are going to be out this way, and the comet's going to be going out into them. All right, so it's a pretty interesting thing. So comets then will always have two tails. They'll have an ion tail, which is what we see here when we zoom in a little bit on this guy. You can see that we have two tails on this comet. We have one, and then we're going to have the dust tail on the comet. So that is something that is part of what we're talking about. Okay, we'll always have two tails, the dust tail and the ion tail. All right, the dust tail is what's left behind in the orbit, and that dust tail is also the thing that if we ever pass through a dust tail of a comet, we see a meteor shower. That's where meteor showers come from. So Amanda, is there more questions? Okay.
Okay. Philip asked this, and I find this hard to believe. So I have a question after I ask his question.
Okay.
Philip wants to know, why hasn't NASA used their equipment to take photos of this comet? My question is, have they not? How could NASA not have?
No, it's not that NASA has not. It's just that we actually have had many photos of the comet taken.
That's what I figured.
Okay.
By NASA.
Yeah, well, not just NASA, but by observatories all over the world.
Yeah.
Okay.
Well, yeah, that's what I figured, but I figured NASA would be in on it. So when I read that comment, I was like, did they not? Why wouldn't they? That doesn't make sense. So
well,
okay,
no.
they did. Can we see them? Are they at like NASA.org or anything?
There's photos. I mean, I'm sure that. You see, the trouble is, for an observatory to take a photo of the comet, we have to make sure that the comet is actually in a favorable position for the observatory to take the picture of the comet. So, for instance, space-based telescope, like the Hubble or something, could it be retasked to take a photo of the comet? Maybe. Maybe it has, and we don't know it yet. I don't know if it has a picture of the comet that's been taken. But generally, these objects are followed by NASA quite a bit, and we should see some of this data. And I'm thinking that it's out there. I'm thinking that it's been taken, but I can't tell you for sure. I'm going to look for it though, because when we talk about comets on SkyTour Radio this Sunday on kgraradio.com, a little shameless plug there, 8 to 10 p.m. Sunday night. Our show is all about astronomy, and Amanda, of course, is the co-host, and Daryl will be joining us. He joins us as a observational astronomer, and we may talk about comets this weekend. If I'm writing the show now, and I'm thinking we might make it a comet show. And I think that it'll be a really good show. We'll talk about comets.
You know what I was thinking the other day?
What's that?
I started mixing everything up. And I know this was probably one of the first questions I ever posed to you. And I am certain that we did at least one full show. If not, it may have been broken up into two, because there was so much to talk about. The difference between comets and asteroids and... What's the other one I'm thinking of? Meteors?
Okay. Well...
What's the difference between them? What are showers? Like, some people still call them shooting stars.
Yeah.
Can we have an asteroid shower? Can we have a meteor shower? Going through the tail of a comet brings a shower. I mean, how do we know what is what, I think that would...
That's actually a pretty good...
right now, you're looking at a comet, and our friend Bill is watching a meteor shower.
Yep.
At the same time. So, I mean, people look up, they might be seeing something, and they don't even know what they're looking at, or why they happen the way they do, you know?
Yeah.
Does it all break up the same? Is it, You know what I mean? I think.
Well, I do.
I think that would be a nice refresher again.
Okay, so you think maybe this Sunday's show we should talk about comets and asteroids and all that? I mean, that'd be sort of an elementary show. That's good. I mean, some people need that.
Well, I forget again. And I know we've had a whole show about this, but, it's not something that I think about often. Like, it's not something I'm practicing every day. So, unfortunately, like, if someone asked me, there's no way. There's no way I'd be able to explain it to them,
Sure.
But I think, like, we pass through the tail, Earth passes through the tail of a comet for certain showers.
Yep.
But then, like, would it be an asteroid passing us that causes a meteor shower?
No, I mean, remember I just talked about the two comets that tails always have? I mean, two tails that comets always have? Wow. The dust tail of a comet is the thing that stays in that orbit of the comet. It's that little tiny particles of dust and debris, sand grain sized stuff that was sloughed off the comet by the solar wind interacting with the particles and carbon compounds on the comet's nucleus. The stuff you see around the comet here that forms the coma, this is ionized carbon atoms that form this greenish color. And when we look at this greenish color, it's composed of compounds, and those compounds can be making up dust grains and so forth. And these dust grains are things that are going to lag behind the comet. As we saw in previous photos, when we look at the comet, right, we see that the comet is traveling kind of in a direction like this. It's kind of going down, all right? And those three stars, for instance, are now here. They're up there. And so when we talk about the tail that's being left behind that you don't see is here as the comet's moving through space. The ion tail you do see. The coma you do see. We have a coma, an ion tail, a dust tail. All right. The coma is just the stuff around the nucleus of the comet that's being bounced off the nucleus by the interaction with the sunlight. Okay. So there will be dust, and that dust, if it manages to reach us, if we go through the orbit that the comet took at one point, then we will go through a tail of the comet from however long ago the comet occurred, okay? And because that debris stays there, orbiting the sun forever. And we see this debris, and when it enters the Earth's atmosphere, it burns up and forms a meteor shower. Okay, so cometary tail debris makes meteor showers. Asteroids don't make meteor showers. Asteroids are larger rocks in space, from several meters to hundreds of miles across. And the larger ones are also called dwarf planets. Pluto is called a dwarf planet now, but it's not an asteroid. It's a dwarf planet because it's actually round. It has a round shape, kind of like the what used to be called asteroid Ceres, but Ceres is now a dwarf planet. So, because it's round as well. So I think that it's pretty, pretty good, the way this works. And Daniel Whitaker, that's why I was having trouble with it. Chimera was the name of the spacecraft, I believe.
The first Centaur mission. Yeah.
Yeah.
Thank you, and don't worry, that's okay. I'm just thank you for letting me know. I kind of, wanted closure on that.
Yeah, I mean,
since you couldn't answer it, I'm like, I wonder what that was. So
yeah,
cool.
Yeah, and when he mentioned it as a spacecraft, now that my mind is thinking spacecraft, well, yeah, I do remember the Chimera mission, and it wasn't spelled that way. It was actually like Chimaera or something like that. So it was. I mean, it's not a big difference, but I was thinking an asteroid type. I mean, I know there's Florian asteroids, there's other kinds of asteroid families. And I'm thinking Chimera, you know, and I thought, wow, there's something I don't know, and I was wondering if I was, you know, all there. But thank you, Daniel. Thank you for checking that out and telling us about it.
And you guys have to bear with me too, you know, as I'm the one that's kind of grabbing the questions while Mark's doing everything else. Sometimes if I don't understand it, I try to fill in the blanks and I try to interpret what I'm reading and kind of guess at what you guys are asking. So please, if you ever hear me like way off course, jump in there and correct me. Let me know exactly what you mean or what you're asking, or if you want elaboration or whatever, you know. But I mean, the questions are great. They're always straightforward. But like questions like that, I didn't know what Chimera was either. So I figured he was talking about a comet, and then if a Centaur is a type of comet, then by default a Chimera must be a kind of comet too, right? So that's how I posed it. So, you know, even if he had have known that it was a spacecraft at the time, just based on that question, that's how I would have interpreted it, not knowing, right? So,
okay.
Just for you guys to know, I am not an astronomer by any means. So just correct me when need be.
Yeah, but you're working up to being an astronomer.
I'm trying. I pick things up here and there.
You do. I will say,
wonderful teachers. You and Daryl are wonderful, and this community is so supportive and helpful, and I see them helping each other out every stream. I love it. I love this community.
Have a very
DK just said it too. I love this community.
We have a very good community of people here, and
oh my god, the best.
You know, and when we talk about the Centaurs, okay, and asking whether Atlas could be a Centaur, well, here's why that's a sticky question. Okay, it's a sticky question for a couple of reasons. Number one, any object that's out beyond Neptune, for instance, I mean, the Centaurs typically aren't, but any object that is out past Neptune is probably going to be an icy body of some sort. If for some reason that ends up coming into the inner solar system, then it may very well start to sublimate, melt, and look like a comet. So, is a Centaur object definitely a rocky body? Well, maybe. But it may have a liberal coating of icy dust on it too, so it could be masquerading as a comet when it really is like a 10-kilometer sized asteroid with an icy layer. So there's a lot of things we don't understand. Incidentally, you'll notice that the colors are a little bit washed out here. That is because we are getting ice on the corrector plate. So I'm afraid it means that we're going to be shutting down. I promised you last time that I was going to get the ice protection system. It's on there and it's working, but I'm not using a dew cap right now. That is an extension on the end of the barrel of the telescope, because we were looking in a particular location that would make using that problematic. But I'm going to figure out how to make sure we can actually use it. I'm going to cut it down and attach it to the telescope, so we will have that protection for the next time we stream. All right, but I can tell you that I do think that compared with some of the earlier photos, all right, that's Venus, but compared with some of the earlier photos like this one, okay, we have some ice now that we're dealing with. Ice like on the Comet, right? I mean, it's just, So, I'm going to be shutting down. And just while we're here, just give you guys a little update. SkyTour LiveStream West is going to build the building on June 25th, it looks like. I'll be out there on the 22nd. And we're going to build the observatory on the 25th. It'll be all one day. And then we're going to have the roof and the building separate. And then we're going to get a company that does garage hardware to come out and examine the building, because we're going to be then putting the roof on garage door rollers and attaching it to a special garage door opener, which is a little bit higher wattage. And then it'll all be something that I'll operate remotely wherever I am. So the idea is that SkyTour LiveStream can run from anywhere in the world. No matter where you are, you should be able to run it, And I don't want to let the cat out of the bag yet, but it looks like the second pier that I told you was going to go in that observatory has been spoken for, and we might now have another tenant in SkyTour LiveStream West already, ready to take advantage of the Sonoran Desert out in Arizona at 2,000 foot elevation. So that's kind of cool, and we're looking forward to that, and we're hoping that comes to fruition. So anyway, I want to thank all of you wonderful people out here for coming out.
I'm sorry, there were still a few more questions. I'm sorry we weren't able to get to them all.
Oh, well, how many more?
1, 2, 3, 4.
Okay. These last 4 questions I will take. Go for it.
Okay, we'll try to speed through them. Now, I don't know, this is kind of random. What's the big deal about April 29th? Is something happening on that date?
What's the big deal about April 29th?
Yeah. Something in the sky happening? Anything with the comet? I mean, we just passed a meteor shower, so I don't think another one will be coming up that soon. Any launches?
No,
I just thought if it was something big, maybe you'd say, oh, they must mean blah, 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 but I don't know. I mean, it doesn't...
No, actually, there's let me just get the proper, I don't know if it's April 29th. I don't want to be confused here by something. I just want to get the details. 1 second. I think what's happening, if that's what I'm thinking of, I'm looking up some details. Okay, that wasn't April 29th. It was actually May 23rd is the closest approach of Comet Atlas to Earth. And it's going to be about 73 million miles. And then on May 31st, it'll be the closest approach to the Sun. Okay, so...
Philip is suggesting 1998 OR2 asteroid flyby. Potentially near Earth object.
Yeah, no, that's going to miss us, though, with room to spare, by far. Yeah. Definitely.
Well, I mean, that might be still what they're asking about. I mean...
Okay.
I have no idea.
Okay. It might be that particular asteroid. 1998 OR2 is definitely an asteroid that's right now it's in the constellation of Cancer. So basically just eastward of Orion. And trying to think of, it's something we can actually see from here, but it's magnitude's 11.9, so we could certainly see it with a telescope. It just has to be at a good spot in Cancer, but Cancer is setting, so it's not now is not a good time to look for it. We should have looked for it earlier tonight.
What, this near Earth object?
Yeah.
Ooh, next time we're definitely doing that.
Okay. And we could.
Oh my god, guys, whoever's left in chat, please remind me. Next time we stream, I want to see this near Earth object coming towards us.
Well, it's not going to... I mean, the closest approach already occurred. I'm sorry. No, it didn't.
No, well, is that... No, he says the flyby on the 29th. I thought he meant it'll be the closest to us on the 29th. No, maybe not then. So what... Oh, okay, so what does that mean? Flyby on the 29th? We'll start to be able to see it? I mean...
No, generally the flyby...
somewhere, right? I mean...
Generally a flyby means that it's going to be at closest approach to us when it's going to be here. Okay? So it's really not going to be that bad. I mean, like I said, at closest approach to the Earth, it's really not going to be. It's not going to be that close to us. It's going to be a really quite a safe distance away. However, on April 17th of 2079, the asteroid's actually going to be literally just 1.7 million kilometers away. And for those of you that want to know what that means in our units, let me do that for you. Let me just grab that value so you see what I'm talking about. 1.7. And you can listen to the music while it's happening, you know. Yeah, it's did I get that right? 1.7. Oh, shoot.
Did you forget to carry something?
No, I didn't. I just actually, I wanted to put in the whole, the exact value, and I just estimated it, and I got it wrong. I was trying to do the right value. All right, so let's see. Basically, in 2079, that guy is going to be coming to within about half the distance to the moon. It's going to pass between the Earth and the moon, basically. That's in 2079. All right, so it's going to be it'll be 118.
A near-Earth object is going to be between us and the moon on the 29th?
No, in 2079.
Oh.
That's asteroid 1998 OR2. So I don't know what's happening, you know, on April 29th. Is there actually a?
I don't know. Philip is saying that it's going to be at its closest approach to Earth.
I mean, he could be right. You know, it might be.
Well, it's going to get a lot closer than that in 2079.
Yeah, well, it's going to be a very safe distance this time around.
Yeah. Wow. But then when it comes back, so okay, is that a correct statement? When it comes back, or how many orbits until 2079 will it make?
I don't know what's period. Let's find out.
Sorry, no, it was supposed to be just one more, but
its orbital period is its orbital period is just over 3.5 years. So so
I guess it'll be coming closer and closer to Earth every 3 years then, until it gets between us and the moon in 2079.
Yeah, something like that. It won't be getting closer and closer necessarily. It could actually be in a complex path that takes it closer to us. Because every time it passes into the inner solar system, like this, I mean, it's a near-Earth object, but every time it passes into the inner solar system, it's also going to, be affected by the gravity of everything else, and might change its orbit a little bit each time. So that has to be taken into account as well. So.
Well, that's where I was gonna go with this next question. I know. I'm sorry. I'm killing you.
No. But the question again. This is still question 1 of 4 that we had, right?
Yeah.
Right.
Okay, well, yeah, that's what I was thinking. Like, I guess it'll disintegrate a little bit more and more each time, right?
Comets
do. Orbits, but...
Comets do, but asteroids won't. Asteroids are made of rock, and comets are made of what are called volatiles, things that melt and sublimate, okay? Asteroids are not made of those things. Asteroids are made of rock. Okay, so they don't disintegrate each time they come around the sun. They actually would stay intact. Asteroids are big rocks. Comets are basically snowballs. Rocks outlive snowballs.
But they must disintegrate at some point in some time.
Not necessarily.
Really?
No, most of them have been here for 4.6 billion years already. are the same as they were when they were made. I mean, they could collide with each other out there in the asteroid field, maybe. Or if they go into a complex orbit, they could end up being ejected from the solar system or colliding with something else or being tossed into the sun or into Jupiter or some other thing, yeah.
Okay, well, then I have, I don't know, experiment I would like us to do next stream, too. I can't remember the site where you play with the size of planets and throw planets into other things and this and that. Remember?
Yeah, that's the
Sandbox?
Universe Sandbox too. Yes.
Yeah. Okay, because we're gonna have to play this out as if this comet is every 3 years, you know. Because well, if it's going between us and the moon in 2079, what happens 3 years after that? What happens 6 years after that? I mean, is it gonna get? Yeah, I mean, will it eventually? You say it's gonna miss Earth. Is the gap in between orbits like so big that it'll go between us and the moon in 2079, and then 3 years later it'll like be behind us, like maybe between us and Venus or something?
No, it's actually more complicated than that.
Oh, lovely. More complicated. Just what I was looking for.
Yeah, no, it's more complicated because when a comet is traveling through space, an asteroid is traveling through space, it could end up getting, perturbed by something, and then moved a little bit. Like I said, as it comes through the inner solar system, it may very well find itself being pulled by something. Its orbit is changed every time it comes through. A little bit, a little bit. I'm responding to a request to pass through the pictures from tonight of the comet. Okay, you see those 3 stars, and you can see them, and you'll see how the comet is moving over those 3 stars. There they are again. Let me zoom in a little more. Okay, right there. Okay, now watch those 3 stars. 1, 2, 3. See those little ones? And then we're going to see, now you can see where it went from there. Look at that. It's there, and then it's to the right and below a little. A little more. A little more. A little more. See? Okay, a little more.
It's crazy.
Yeah.
I hope you guys are able to see this too.
Yeah.
It's very gradual, frame by frame, but
yeah, that's actually I'm responding to a request to actually do that, so they can see. And this is just tonight. This is just one night. It's really starting to speed up. It's really starting to speed up. But I do have to close up, guys, because I'm getting ice on there. This gray pall that you see here is definitely ice on the corrector plate. Not a good thing. But I do want to thank you guys for coming along and hanging out here. We've gone for 3 hours, 45 minutes or so. So we actually had a good time. I'm a bit tired.
Thank you guys for all your questions.
Oh, the questions are great. Just read the other questions just so I have them.
Okay. Philip says, has anyone looked into the meteorite that struck Akure in Nigeria on March 28th? Left a 21-meter wide, 8-meter deep crater. Local police government claimed to be an explosion from a truck carrying explosives. Have you heard about that?
Was it an explosion from a truck carrying explosives, or was it a meteor?
I don't know. I guess he's under the impression that it was a meteor.
Okay.
Or a meteorite, I should say.
Well, that's interesting.
I mean, I have never heard of it. I didn't look into it, but
I haven't either because I didn't hear about it.
Okay. Farva wanted to know what your opinion was about the impending black swan events.
My opinion of the black swan events?
Yeah.
I don't know what the black swan events are.
Isn't there a swan comet coming up or something?
Black swan events, though?
Oh, I don't know. Wasn't there another comet?
Yeah,
Daryl was saying.
Yeah, Comet Swan. Yeah.
Comet Swan, yeah. I don't. Again, I'm guessing. I fill in the blanks all the time. I don't know.
Well,
maybe. What are your opinions on Comet Swan then?
Well,
I guess you don't have any on the Black Swan event because you don't know what it is. I don't know what it is.
No. Black Swan is really. Black Swan is something else. It has nothing to do with astronomy, really. Basically, a Black Swan event describes something that happens as a surprise. Okay. All right. So this is not what. If he's talking about that, I'm not sure that I don't know of any Black Swan events because they would be a surprise necessarily. So
yeah,
I wouldn't know about them yet.
I guess we'll be surprised.
I guess, which I don't know.
And you just wanted to know when the comet would be closest to the Earth. I know we've mentioned that a few times. I think they were a latecomer, so.
Oh yeah, no, that's an excellent question. No, it'll be closest to the Earth on May 23rd, and then on May 31st it'll be closest to the Sun. On May 23rd it'll be about 73 million miles from Earth, and then it'll be passing the Sun within the orbit of Mercury. So it's going to be very, very close to the Sun. And to know how close that is, comets don't generally pass within the orbit of Mercury to go by the Sun. They typically pass outside. But this is going to put it in some jeopardy because it's already fractured and breaking apart. And when it goes around the Sun, now there's going to be several components, possibly 3 components, that are now going to be able to have the full radiative impact of the radiation and heat of the Sun. So I'm not hopeful that the comet is going to survive going around the Sun. I think it's going to be done. I really do. I could be pleasantly surprised. I look forward to it. In astronomy, a lot of things don't seem to go our way at times. What we think we know is slammed back in our face pretty hard, and we're like, hey, you don't know this. Oh, I guess not. So I guess we'll see, right?
Wonderful.
Yeah.
Okay, well, that was officially it. Yeah. I mean, Farva says the basic swan, not so black. I'm not sure, again, what that means, so. But yeah.
Well, I mean, Comet Swan is, let's go to Comet Swan, only because the word swan is in his statement. He may not have meant that at all, but okay, Comet Swan is in the southern sky right now, but it'll make its way possibly to the northern sky in the morning after it makes its way around the Sun. So we'll see it, perhaps. People in the southern hemisphere can see it now, but it's going to be, I think like Atlas. I mean, it's probably going to appear like Atlas. I'm not sure. You know what? We can figure that out. I think we can figure that out. So let me figure that out for you right now.
Oh, your poor telescope. See what he does for us, guys. I hope everyone's showing him the love by hitting the thumbs up and.
Oh, they're good.
Tell your friends, share this on social media.
Oh, they're all good.
You might help someone. Make it through the evening.
Oh, they're all good. They're all good people.
Yeah.
Yeah. See, Comet Swan is brighter than Comet Atlas. I mean, Comet Swan's magnitude 7.4. Smaller numbers are brighter. It's in the constellation.
If Atlas had held together, would that still be true? Would it have been brighter than Swan?
Atlas could have exceeded Swan if it held together. So
will Swan be able to be seen in the daytime sky after it passes the Sun?
No, I don't think so. I don't think
Atlas
so.
had that potential, though.
It at one point, but no longer.
No.
Yeah, I don't think it's going to be visible. I think it's going to be gone. Just my thoughts. I don't know. Yeah. Yeah, so, and hey, I mean, the closest approach of Swan is going to be 148 million miles away. So literally double the distance of Atlas. Okay. And it'll be just, impressive if we could see it. But I'm not sure we will be able to.
But we can try.
Yeah. Actually, no, the actual distance now actually is 148 million miles. All right, but it's actually, when its closest approach, it's actually going to be 85 million miles. So it's going to be a little bit farther away than Atlas. Okay, its closest approach. So that's pretty cool.
You can hear me typing.
Yeah, I do.
I'm just answering Philip when we're doing your next live stream. Gotta subscribe and hit the bell. Depending, I mean, we might have the best of intentions of doing it every night, but clouds might come in, things might come up, right?
Yeah.
It all depends on the sky. We can't really plan it. So the best thing, not only subscribe, but hit that bell and ask for all notifications. And then whenever we do go live, you'll get notified and you can join us.
Yeah, that's true.
I mean, Mark tries to do this as often as he can.
Yeah, we do it.
Sometimes he travels, and we have shows Sunday night, and he's a guest speaker on a lot of shows, and just a popular guy. It's hard being Mark, but clouds mainly ruin our chances of streaming.
Yeah, they do.
More often, yeah.
Yeah. But hey, like I said, with SkyTour LiveStream West, we're going to have 2 functioning observatories in the SkyTour series, and maybe down the line, we're actually looking at getting a 3rd at another place in the country where we can actually have a clear sky every night to do astronomy. I think that would be pretty cool. Yeah, that would be cool. So we want to do that. Anyway, for now, guys, I will leave you with our night sky as we see it now. The Big Dipper.
And for those that can't sleep, I put a link in chat a few minutes ago. Yeah. Our friend Bill Skywatcher, Bill New York Skywatcher, is over streaming right now, so feel free to join us over there. Last night was the actual peak of the meteor shower, but you never know. There might be some stray shooters tonight, so.
Yeah, it was kind of a dud last night. There was only one or two.
I mean, there were a few pretty ones with green tails, but. Yeah. But I mean, it was pointed out that it was a minor shower,
Yep.
But still, we were looking for 10, 20 an hour is what I thought I heard.
Yeah, I'm really hoping for the Leonid shower of from the past. There was a Leonid meteor shower where, when you looked in the sky, all you saw was streaks. It was literally unearthly, and it was before any of our times for any of you listening. And it was just supposedly stunning. And I've never seen it. I heard about it, and I really want to see a meteor shower like that. It looks like the coming apocalypse, I'm sure. You have bright streaks in the sky. It's like being invaded by space rocks. Oh.
I remember seeing one when I lived in Pickering, Ontario. And I don't know. It was unreal.
Really?
It was unreal. I could not believe what I was seeing. Yeah, I mean, even if you had paid to go to a professional laser and light show or something, they couldn't have put on anything near as good as this.
Well, I saw one, that went.
But I don't know what it was though. I mean, I'm thinking it was Hale-Bopp, but I don't know. I'm trying to remember the year. It might have been
a comet?
I don't know.
Or a meteor?
1990, maybe?
Was it a comet or a meteor? Comets just sit there, as you see on the screen for us tonight. They move slowly through the sky, but meteors are fast. Never lasting at the longest, maybe 20 seconds in the sky.
It was just constant streaks of light in the sky.
Okay, that sounds.
It was a meteor shower.
That sounds like a meteor shower, yeah. Wow. All right, well, thank you guys. Thanks for coming out. I really appreciate all of your efforts to come out and see little old me and Amanda and Daryl. And we'll be back on the next clear night, I promise. But please do subscribe and hit that bell if you haven't yet. I really want to see you come back. All right? So we'll talk to you next time around here on SkyTour LiveStream. I'm going out to close up the observatory, and then I'm going to bed. I've been up since 7 o'clock in the morning, and it's like 12:30 right now. And, I'm just, I'm running on empty, running on, that song.
I do.
Yeah. So anyway, I will talk to you guys later. And Amanda and I are out of here, and we will see you next time.